Yeah, it's possible. Okay. Hi everyone, apologies for that. Our wire stream went down, but you're back with us. We are just still traveling up to the top of a feature known as P-Vent, which in 2017 had water temperatures measured at 289 degrees Celsius. Z, do you remember what orifice you measured?
It was down on, we haven't
On the
seen it.
flanks.
It's probably on the other side. It's not a good place to sample. It's the best we do.
But there's more, you think, on the other side?
Yeah, so
Down the side of south side?
This is the south side.
after we images, can we drop down and look at that little chimney, see if it was still hot?
On the south
I'm
side?
not sure what chimney you're talking about here.
We
Coming.
went over and it was right down
Okay.
here.
A little squatty one. Okay.
Yeah.
And that was 289?
It was 289 when Jill sampled here
Mmm.
in 2017.
I wonder if we have those pictures.
This changed?
It seems like it's changed.
It hasn't changed a lot, if I remember, but I don't remember this one as well. We're so focused on just getting water.
From
Yeah,
from the 2017 paper, it's changed a bit.
because we could land it there, stand pretty clear. I'm not sure how hot it is.
Yeah, I don't either.
Yeah.
I'll zoom in. I don't see any shimmering water, Z.
Okay.
Those are neat to sample, though, Victoria. I don't know if they were active in 2017, but not now.
Yeah.
I don't know. We'll just keep going around.
Want to
So,
mark it?
can we mark this waypoint as?
What do you want to call
What do you want to call it?
Chimneys for sample.
Yeah, well, this isn't going to be for water, but this is just.
Yeah, for microbes.
That's what looked like some mat on the other side of this where we couldn't land actually.
it? Chimneys for sampling?
Yeah.
Sure. Not yet.
Yeah.
I feel like we came in from this direction.
Yeah.
We'll just make our way
I think
around.
there's a place you might get doors right at the time.
No,
Yeah.
that's some big statement there, Z. Coring.
On the other side,
Cores.
so I don't go turn
On the
Sure, sure.
hill.
Yeah. However you need to.
That'd be fun.
It's, it's been low long enough filled in with sort of hydrothermal sediment.
There are lots of these little tiny little structures. Or nothing. Can you grab the little wand?
Yes, here's the one.
Oh,
Can you
yeah,
kind
yeah,
of
that
zoom
one.
guy
Exactly.
see if he's hot?
That's the one I was just about to look at for the
One
mic.
sticking out the top here?
I don't think so, but there's a lot of those little
Yeah.
fun features. I feel like it's been kind of overgrown by.
Less active.
Right.
More, the two dwarfs don't look as happy as what I remember.
That's what I was thinking. It's changed
Yeah.
quite a bit,
I
actually.
think it might have.
Yeah.
Starting to.
Yeah, that's pretty
Sputter.
dead looking.
It's starting to sputter.
Well, I don't think it's dying. I think it's just plugging. You know, I think fluid just moves around.
Yeah. So
look
the
at
plumbing moves around quite a bit in these systems, and
Yeah,
so
so
if you're a
you're thinking
tube worm attached to the
maybe there's-
seafloor, well, if the plumbing
Coming the other
changes,
side, you
you're
might
kind of
get
out of
into
luck.
That stuff I don't know.
All right, making our way around this feature just to get the lay of the land here.
Yeah, they were much happier too. Much up at the top than we were here before.
It'll be fun to do the same sort of thing, the early photos versus now.
Yeah,
Yes.
I'll have to dig up the Mbari footage to try to exactly match. It's also different from my memory as well, Menzies. So I do think it's changed. Like all those ferry chimney structures fall down, and if they're not there as a reference point, you've just got the
Right.
mound covered in tube worms, and so it's a little bit tricky.
Yeah. All these places where it's really coated,
Mhm.
really shimmering water.
Sure. Yeah.
That's not good.
And these start to form as well, but then they stop.
Right.
There's definitely some shimmering water in there. A little radiated.
Microbes don't lie.
Thank goodness for the microbes and their surface expression of what is going on. Yeah, so the Oasisia settle as larvae, and then they end up as non-moving adults, getting sulfite and oxygen for their symbionts. So they're pretty much stuck in place once they make that move. And is that the same ones we were at now, or
Correct.
those are? Yeah. Okay, so that's right. I think that could be the hottest area. This would probably be a good slurp for Greg, though, in these sort of intermediately active Oasisia. All right, what do you think? Do you want to try to see if the river of bacteria is corable?
Yeah. There's a Riftia. There.
Sure is. The lone Riftia again. Oh my gosh. Ah, my PhD subject. It's been so long. Just a single. They're so rare here. They're abundant in the Guaymas Basin and north of us. These Riftia, the larger red tube worm we're looking at here, they're related, of course, to Oasisia. It's out there in the distance.
So this one, because we're on top of this mound,
Yeah.
I think we just choose one little part.
Okay.
To
You want to go
get
around?
really nice and bright, fairly low.
Okay.
And fly over a couple of times, and then we can do a model.
Okay. Do you want to relay that to? Okay.
Just that.
Nice and bright. I actually don't have iris, so something else is gonna be nice and bright.
Yeah, that kind of depth.
Is that good enough?
Yeah, that feature would be great.
All
Nope.
the way around?
Yes, please.
We can just keep it like this, since we're gonna do photogrammetry. Nice and bright, Greg says. So this seems good.
Maybe iris down a
Oh,
little bit.
I can't. So how about iris down a little bit? Sorry, Adam. How about that?
Okay,
Perfect.
that's perfect.
Thank you. Okay.
Yeah, this would be good.
That looks good.
So we're gonna fly around at a constant distance from the structure here to get some footage so we can do some 3D reconstructions. Ah, did we do that? No, oh, this is just floating away. Can't be. It's weird.
We're watching dispersal in action.
For sure, no. Test that hypothesis. So did you noted, oh no. You noted this river of bacteria? Yeah, we know. Tell them they're working on it. Okay, so we're back. We are still doing our flyovers for 3D reconstruction and also getting the lay of the land here, deciding where to sample.
Just back around, just down this way, and then I think we'll go.
Jenny's working on it.
Yeah, she had put together some maps for me. We only took 2 animal samples here in 2015, and since then nothing. So we really don't have very many collection events.
Yeah, that's good.
It seems like a slurp in a sort of moderate active OSSC would be good.
Thanks, Joe. That's right.
Okay.
Let's turn out.
Yep. Getting a turn out of our tether here. These Oasissia were really surprisingly abundant at these sites in the Auka Vent Field of the Pescadero Basin. We have never seen Oasissia in this abundance, and we calculated them to be something like 2,000 individuals per meter squared. So they really love these sites for some reason, end up settling here and thriving. We do see them at other hydrothermal vents nearby, but Riftia is usually the dominant species. So they've kind of flip-flopped in dominance here at this site. Okay, so we're coming around what appears to be the main, hottest, newest feature here. Getting a closer look again. And then we're going to make some decisions on what to do next. Have you seen the dive plan?
The dive plan.
Yeah. Do you want to just
Well, it would be great to see if we can try to find some place to core.
Oh, okay.
And test
Yeah,
these
so
ideas.
around there was a little river of
Yeah.
bacterial mat.
Just see if it
Just
doesn't
kind
have
of
sediment
rotate
on it
back
there.
around. Sorry, the way you
No,
came.
you're right.
Mm-hmm.
Did you see anywhere from water?
Yeah.
I feel like it was on the west side, the river of bacteria. But you keep doing what you're doing there.
There's one right down in there, and the others to come in right in here.
They hit
That's hot enough.
they
Those
hit
are
their
the-
rear end on the wall if they were on that side because we tried to do a fly around. Mm-hmm.
I think we might be able to come in here and get to those.
To the side.
Yeah.
And even if it's diluted, it'll be useful. Huh?
Well, if we can't get a good orifice, then I would rather not try. I'd rather go to Z-Vent where I think we can not only get a better sample, but probably do it quicker. Because I think the setup here is going to take.
This setup is tricky.
So I'm still looking. You guys sample.
Yep.
You also.
Setup's going to be tricky at Z-Vent.
Oh yeah.
Well, there was the big flange. There was a corner.
Keep
that
going.
We could park right there.
It was definitely on your fly round, so we'll
I have
just.
a place
Okay.
picked out.
There's a kind of a ravine that looks like a little river of bacteria, so we'll just.
And get a
We'll
good
see it.
sample, so.
Well, we could.
Oh,
we could
I don't. Yeah, it's not on the west side.
At Z-Vent to do
See.
that and do the chlorine if that's a better water sample. So just do
Yeah, I mean,
mostly animal
I'd
sample
really
there.
prefer one here, but I think
That is a little
I'd
beehive.
rather have a good one than one here, so
Yeah.
I'd rather go to Z-Vent right
Same.
now.
Same with you.
You know, I'm happy to look around with you guys sample a bit and see if we can find anything better. But right now, I think Z-Vent's a better shot.
Okay.
These are so cool. Is that a P-vent image?
This is Nautilus.
Nautilus P-vent. Mm-hmm.
Another wrong drift here on the right side of the street.
Yeah, we've seen a few of them. I wonder if that's this growing, the big feature. Nautilus would be helpful. That's great. There's the Riftia.
Their arm is in front of their face.
I know. They're also. Are those sperm packets? All the white? Oh no, those are little pinnules. Okay, we're keeping going here. Let's see. It's got to be around here somewhere. Did you want to try to pour here in that little depression, or now you're
Yeah.
thinking Z-vent? Okay.
Well,
Oh yeah. Wait. No. Let's back up.
Well, I think-
back up a little bit.
I think we should try to use maybe the temperature probe to see
Yeah.
how,
Yeah. For sure.
how deep it is.
Yeah. Having a chat here with the pilots. It's not the easiest place to fly. Can we look down now to our left just a little bit? If we can just. Is it. It's not this. We're just taking a. Okay, we'll keep going around.
To the left or right?
To the right. Trying to get the vantage point here. Is that Mayor McCheese?
Must be
Mm-hmm.
10 minutes of better cheese. It's a very short course.
Oh, that's hard. Alright, going back around.
It was before that. Oh yeah.
So it pretty much looks the same in 2017. Like lots of little spires.
Yeah.
Alright, there it is. So we wanted to try to set up over here.
Okay.
And use the temperature probe to see if any of this white microbial mat is coreable, so you can sit pretty much anywhere. I told you the exact wrong direction, how we went all the way around. It's on the east. Just like I said, it's on the east. So whatever's easiest for you.
Yep.
Yeah.
Look. So you want to soften up?
When it's working, I can't. Yeah.
Okay, so we're gonna set down here and try to see if this sediment underlying this white bacterial mat is coreable. And we do that by using a temperature probe that can not only give us the temperature of the sediment, but also tell us how deep the sediment overlay
Can I do it
is.
in this valley?
Yeah. Thanks. I don't. That's what I was thinking. Nice healthy clump of Oasis there.
It's delicious.
Use your teetering laptop as a table.
Yeah, well,
It's only a riftia with a friend.
Where are you looking, Z?
There's a pair of riftia off to the right.
A pair, finally.
Finally one with
Finally,
a friend.
a pair.
Every time I see them, I think of the Elton John "Candle in the Wind."
The Riftia?
Yeah.
Oh, funny.
Yeah, I don't think so.
I don't know. The
Yeah,
It's slurpable, but it's not horrible.
Well, we'll slurp.
yeah. Yeah, if you're set up.
Uh huh.
you can do some
We will.
animals,
Yep. It does look pretty rocky. It's
Yeah.
wishful thinking over here. Wishful thinking by the microbiologist that they could.
That was
Plunge a
that was
push core in here.
suggestion from the geologist.
Yes.
Second guess.
Uh,
It was.
never want to second guess a geologist.
Yeah, because you know he's wrong on the first guess.
Alright.
Yeah, Z says
Yeah,
both
so
things.
temperature probe first, right?
Yeah, let's just see. Yeah. Let me get it out. That's pretty tricky. Can the drawer slide out very far?
You could shove it under your flow
Okay.
Move it.
if you have it out.
Yeah.
Looks like it's some good slurps under there.
Uh huh. Definitely. We could do mat. We could do bushes.
You see, you got a little bit of flow there too.
Wow.
Yeah, that-
Why are the tube worms red, Sean?
Got that.
Oh.
What's
Why
the
are the-
purpose of the pigment?
Connor knows.
Okay.
I'll tell you though, they have 3 kinds of hemoglobin. 2 in their vascular system and 1 in their coelomic space. So they act, the tube worms, the question was, what's up with the red color? They have hemoglobin, 3 different kinds that bind oxygen and sulfide reversibly, so they can take oxygen and sulfide to their symbionts, which are down in a special organ known as the trophosome. And those worms have a tough job hosting those bacterial symbionts, because not only do they have to take up a really toxic chemical, hydrogen sulfide, but they also have to deal with all the waste products of those bacteria. So it is a true compromise, like any relationship. You know, there's the dating, there's the negotiations, there's the long-term commitment, and then there's compromise.
Now you can see the two riftia.
Oh yeah, I do see them. Well, is it 2?
Just above
Oh
the.
yeah.
Yes. It's a pair. But it's not a pair of almanacs.
Mm-hmm. It is a pair.
Wow.
And they're snuggling. Oh, look.
Smuggling Riftia.
Look at them. They're like, do you feel out of place here?
They look very happy.
They do. Bright red plumes.
How fast they grow. Be specific rise.
3 feet per year. No, 3 meters per year.
Yeah, I was gonna say.
No, 3 feet per year. 1 meter. They get to about 2 meters high in certain locations. They grow very quickly, actually. So this is another example of how effective this strategy is. So they have no mouth, no digestive system, no way to feed themselves. And so they rely exclusively on the nutrition provided by bacterial symbionts. But you can see that it's a really effective strategy. Essentially the foundation. Can you iris up a little bit? I have lost my iris again. Or I'm just way off to the right, but I also don't have iris control. There we go.
Yeah, you was from
I did.
Oh, you did.
Oh, there's 3 people controlling the iris.
This is from Jenny in right arrow.
We're gonna grab the heat flow probe
Yes, please.
for the.
Also, definitely happier Oasis. Yeah,
You wanna-
this is all. So where is this? Is the fairy castles, and that is missing.
Castle has fallen.
The castle has like all this.
And
Yeah,
venting.
and venting. It's quite different, I think. Okay, that's helpful. Thanks, Jenny. Do you wanna put the probe there?
I wanted to see if there was fluid coming out.
Whoa, going to the left. Right. This is very sensitive, I think. Okay, here we go.
Come
So different.
The big flange is
Totally
not.
different, yeah.
So it's just
And a lot of the
this-
fairy
this whole
castles.
thing
This
with
baby.
fairy castle just dropped off.
This
Dropped
may be
off.
regrowing from near the same place.
Yeah.
So we've been checking our
That's probably s-
footage from 2015, and the site actually looks a little bit different. So there was a big flange with these what we called fairy castle chimneys at the top of it, and that's all seems to have fallen off. And maybe that's part of the rubble we see down below as we were coming into the site.
Yeah, because
I mean, that yeah, I don't know. Is there? I don't think Ambari does heading overlays, do they?
no, it's got lat long.
Yeah, they. Yeah.
But I was just looking to see if these.
Mm-hmm. Match
If we
anything?
swung around the other side
Mhm.
here, if these.
Or
larger
is that one in
chimneys
the
could be
middle?
that one,
Mm-hmm. The thick one
But then this stuff has
dropped off.
dropped off.
It's possible.
Maybe. Use one.
You're doing camera, yeah. Jared has camera control.
Could be these guys.
Anyway, what was I talking about? I was talking about compromise and relationships. The symbionts produce lots of protons, hydrogen ions, in the course of metabolizing hydrogen sulfide, this toxic chemical. And so the worms have to work pretty hard to regulate their acid-base balance. And so that's the other thing they're really good at, not just their hemoglobin, at taking up sulfide and oxygen, but also getting rid of all those protons. And we measured unprecedented proton pumping in these tube worms many years ago. All right, so we're going to take a temperature measurement. Where do you want to do it? In the mat or just anywhere? In the orange or in the white?
You can reach.
Wherever you can reach.
In the whitish.
I'm gonna pan up a little bit. Yep. So the pilots and the scientists share a camera out here, so we have to communicate and make sure that we don't zoom in on something and while the pilot is using it to maneuver. What do we say? Communication is caring. Is that what we? Is that communicate?
I don't know. What do we say?
It's just you know.
Sharing is caring.
No, communication. Communication is key. Communication is. I don't know. All right, here we go. Yeah. So on the chat, it looks like you have the right idea about symbiosis. They are doing each other a service and getting something in return. And it's true that the worms are basically
Getting hard.
a home for the bacteria.
It's 25 centimeters.
Easily, though.
Yeah, it looks like I go a little deeper here.
All right.
What's
Oh.
the? Do we have a temperature? 22, 23.
You want me to go a little deeper?
Yeah, let's try it. Do you have the high temp
microbiologist.
If you say temp probe, yeah. And this is 5 centimeter with 23 degrees.
We're 15 now.
Oh, and then 15 to.
He's a angiobiologist.
Let's get that one.
If I cannot get it in,
Just hold there for a sec.
Okay. Geobiologist.
Yes, you can.
So this is HT1. Okay.
Okay.
I'm just afraid there won't be anything to keep the core in.
Yeah, we gotta try it.
That's what I expect. but
And then are you ready for the 15 centimeter? Okay, so 15 centimeter
But what if you have to lose?
Great. Nothing to lose.
is
Look at the temp going up.
80. We're at 15. We skipped over 10, so we have 5 centimeters. So it was 23. We're okay. 15 centimeters is 83.
83.
Could be fun.
Fun. Could be fun for the microbiologist. Communication is key. That's yeah.
Yeah.
I agree. Okay.
Sorry about
Victoria, more temperature probing or push
Go a
coring?
little-
Will it go
Like
in
it's-
further?
I'll try a little more. It looks like it's,
bottoming out.
But you've gotten your cores have been about 15 centimeters. Right?
yeah, it looks like it's getting something there.
Okay.
Yeah. Yes, if the core holds, this will be
92.
very
Look at it
useful.
go. See how-
Okay.
Oh, yeah.
So you could do let's say 20.
Yeah, it looks like we're up at the top of the
Is the top 25 or this is 20?
101.
Oh ho! These are some hot sediments
On a hill.
Yeah.
on a hill.
It's in the- All this is hydrothermal.
I'm gonna go up here and gaze at some animals while we're waiting.
Hot, hot, hot.
Mm-hmm.
105.
Such delicate little plumes, so beautiful.
Okay.
And aluminum.
Yeah, because we have a film already from the
Yeah.
or
If you've been following us, you know that these anemones are also host to chemosynthetic symbionts, and that's something that we discovered on our 2018 cruise with the Schmidt group out here with RV Falkor and ROV SuBastian, and that's published now.
Because it's only
And you can see that they are side by side with these tube worms. So this entire group of animals, which is foundational, both the anemones and the tube worms, are fueled by bacterial chemosynthesis. That is taking chemical energy instead of energy from the sun and using it to fuel the production of organic carbon.
on the film. How did you do a film?
107.
Down right there at the Mocasina Palm, right
Sorry, let me.
down there.
Just checking for a palm worm really quick. Our geologist.
That's YouTube. So.
Oh, a Cyssia tube.
Sorry.
That's okay. No, always good to check. Okay, we're setting up. The microbiologists are excited about 108 degree sediment.
Pretty stretched out there.
Okay.
Happy with that?
I don't know, Victoria.
well, it's still
Still going up. We're just it's pretty much stable at 108 degrees.
107.8. That seemed like it's whole. It seems like it's yeah. So
108.
let's do 107.8. Okay.
Yes, Connor. So
We can recover.
we sequenced the anemones, and we do think that the red ones are the same as the white ones. They have different color morphs, and that's not completely unusual.
Let's take your camera.
Yeah, take it.
Now we're at 108.
We got it.
But there is one from the other sites that had a bumpy column that was also red tentacled, and that is different.
I think it's just all that. I don't think there's really any set. I think it's just man.
The hot temperatures are for because of volcanism,
Yeah, I think you got 15, 20 centimeters.
not microbial activity. So coming out,
Gonna have to be like
seawater gets entrained in the subsurface and emerges in these faulted areas.
Yeah.
if you wanted to.
Yeah. That would at least give us that to jump back and see if we don't get the substitute.
Great.
Okay.
You want to take over?
Yeah, we're gonna do. Stay seated.
Yes.
We're gonna let's put in the aluminum core, which for 12 that has the film on it, and then we'll try to capture the sulfur.
Marinate
Yep, and then we'll do a polycarbonate.
while that's sitting. Is it 10 minutes? 15 minutes for the marinade?
And
It-
probably
10 plus.
However long it
5.
takes.
Yeah, I mean,
However long
no,
it takes.
It's pretty. I mean, if there's a lot of sulfite here, it'll be fast.
But I mean, it's 10 minutes is long enough, and if it's shorter, that's okay.
My prediction is the core won't hold up by itself. Be like velvet, it's going to fall.
It is on a
That's
steep.
my prediction. And then you're going to have to
Hold it
while
for
you
10
do the
minutes.
Okay.
Marinating.
That's
I
fine.
think.
It's okay. We can gaze at animals.
Well, we could try to do the polycarbonate first, and that would tell us if it's gonna
Yeah.
fall over.
Yeah. Go.
Okay, so you want to stick a polycarbonate and let go of it and see what it does? I don't know. Why not just
I don't know.
hold it? No,
Yeah, okay.
just
let's-
because your aluminum one is going to be the best one.
Yeah,
Yeah.
let's do the aluminum.
Oh, yeah.
And we'll just have it hold it for
Okay.
5 minutes.
Yeah.
Yeah. That's alright. 5 minutes is.
Alrighty, are we ready?
Yep, we're gonna core.
Yeah, we're gonna
Yep.
core. We're gonna use PC12, one of the aluminum ones. I assume
12. Okay.
it's the aft one in the crate.
12 middle crate.
Yeah, the aft. No.
Yeah, we
It's
we have the
six.
other we have the other set of numbers. It's 6.
Oh, yeah, our basket map is incorrect.
The high numbers today.
Okay. Oh, 6. Do you have a basket map, Manette? Do you see that the push cores are labeled differently?
Yeah, the low set.
So either or.
No,
Oh,
the
no.
back one.
It has
Got
the
film on.
exactly. Our pilots are incredibly knowledgeable here. They keep track of us. Is that you? Okay. You have the iris on your joystick?
Just have it right here.
Oh, on a mouse.
That's right. I just have to.
Yeah, yeah.
open and close
Yeah, got it.
structures. Yeah.
Okay. They really want us to melt a push core. Let's try it.
We won't mount the aluminum. Hopefully.
We're not gonna melt the aluminum.
Those of you talking about us melting push cores, we have been known to do it, and this is why Victoria Orphan and her group had these aluminum core sleeves fabricated before we came out, so we can take high temperature sediments. So first time that's been employed, I think, and it's going well, right? When you
Going very well.
Mhm.
Yep. We're very grateful to Ricardo, the machinist in the Caltech chemistry machine shop, for fabricating these for us.
Yeah, we love them so much. We're going to make another set for our next
Oh,
expedition.
he's made them. They're in my
Oh,
office.
oh,
They're
they've
all
already been made.
They're ready to go. Ready for April.
That's probably brings up a good point that it takes a village to do this kind of science, and the machinist at Caltech helped with these push cores, but it really takes everybody and everyone's skills, which are different, to put all this together.
See our mineral colonization house.
Oh yeah, the haunted house is going down again.
No,
No?
this
It's
is a
just-
different house.
Different one.
Yes.
It's never been down.
This is
We
our-
have
this is
three.
our Christmas
We have
snow.
3. No, because we have the funnel.
Yeah, that was number 1. This is number 2.
We put them both down.
No.
It was just in the library. I feel like I've
Yeah.
Yeah.
Oh my God, who put the doors on? The windows that open and close.
Overachieving. engineering.
Are we putting this at the top of Z?
Yeah.
Or
I can
not necessarily
fortune
but near somewhere near
at Z.
So Adam, do you have rotation on your wrist that we could see the sulfide film?
Oh,
Okay.
but then
just a little strip of it is enough. Yeah.
okay, and then point Victoria
I don't know, where did we do the poking?
down here, down, kind of in that area.
Over here.
Mhm.
I don't know. Somewhere near there. So Adam, you can put that in anywhere in the white sediment that's kind of close to where you did the temperature probe measurement, but not on top of that.
And we also suspect that it might topple, so it's possible we're gonna have to hold on to it.
Where?
there.
Hang on, I'm sorry.
Right there.
Oh yeah,
Mm-hmm.
It is a pair.
2. Para albanillas.
A para
You want to do
albanella.
it over the top of them? No, that would be problematic.
It's up to you. Yeah, if it's
Yeah, well, I mean, they're bio. Yeah, they're changing.
There's another one.
well, why don't we get them in the polycarbonate?
Yeah, we can get them.
Okay, so like we said, Adam, we think that yeah. We think that the core might topple. So I don't know if you have to hold on to it.
So you want me to just pull it back
Go.
up, bracket?
No.
No, core it, hold it in the sediment for
Okay.
5 minutes, and then we'll pull it out.
But you might have to
Yeah.
keep holding it. Okay, so I think up there, up.
It's just fluffy.
Up in here.
So I don't think it'll hold the car up.
So I don't see where we did the temperature probe.
Just hang on
Was there?
one sec. Yeah, it was down lower.
The hit gas tank.
So down here is probably better than somewhere.
We're selecting a location. What do you think? Okay.
I feel like this could be good.
Okay. It's in the steep spot there. All right. So right behind the.
Well, is that,
The gas bottles.
So, Z, what's your thoughts on best chance for thick sediments? So this,
I like them.
Yeah, I did
Where
too.
it's a little flatter.
Yeah,
here?
I was thinking in there also, but what if it's? Yeah,
Yeah.
but that's an Oasis.
But I'd like right where you're pointing, right there.
That's an Oasis.
Hmm?
It's an
Oh,
Oasis.
that's yeah,
You
you're
mean
right,
just-
there?
right.
Yeah.
we can
But
just.
right where you were pointing, I think is a good place to do the
Yeah,
core.
right in here.
Right here.
Yes.
Okay. See it, Adam?
Yep.
Okay. Commence. Yep, I got it. Push for 6.
Jared, take the right one.
Thank you.
There you go. Where you want
Oh, thank you. Take it away. Take it away.
it? 1 and 2 are gone.
Thank you.
Okay.
One special marine.
Pelagics.
No.
Number 1 was your snow?
Yeah.
Okay.
2 is swimmers.
Okay. All right. See if this works. Take him. Yeah.
Right there.
That looks good. Between the two worms.
Mm-hmm. Let's see.
You can see the shimmering fluid.
Mm-hmm. Definitely. You want to do it there instead?
No.
Okay. You could do polycarb. Dun, 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 dun. Dusted those Peril Vanilla. Look at that.
Go, go, go.
It's going. Uh-oh. Oh.
Okay. Well, just hold it in.
Don't go too sideways there.
Yeah, try not to.
No, it's the vehicle.
Oh. Okay. Hold it. Okay.
It's staining quickly.
Yeah. This is a Peril Vanilla that's come out. Maybe.
No,
Yeah. Yeah.
that's not no.
No, this.
Oh,
Yeah, that's the.
really?
Yeah, I think so. It's possible.
He's shy during its plumes.
Yeah, that would be the head, but I don't know. That does seem weird. You want to see your
Yeah, I wanna see.
map?
You see the staining.
Fine.
So that was the same worm that we got, the bitey worm?
Mm-mm.
That's not the bitey worm right there?
The Narian? No.
Who is that?
I think it's a Peralvanellid that got pushed out of its tube.
Oh,
But of course, we need Greg to totally confirm.
Come on, man.
Yeah, we went in at 17:15. It's been 2.5
2 minutes.
minutes. Yeah.
Victoria, it's only been 2 minutes. 2 minutes seems like a really long time. Do I really have to stay
These are the door related.
aimed at your? Yeah. Dun, dun, dun.
Yeah, super flocky.
Yeah. Look at it down in there.
Well, it won't stay, but we'll try.
Well, it might be sticky. Don't we think it could be sticky?
We can hope.
We can only hope. Poor Paravanella.
Still a little tentacle up. It's got one frog coming out. Oh, pull it back.
It's like I can't move now. So we're waiting here for the sulfide in the sediment to react with this film, photographic film that's on the tape to the outside. If you're wondering why we're staring at this.
Uh, 30 seconds. Give it 30 seconds.
We'll do a 5 minutes, 5 minute marinade.
5 minutes.
Going over here just to say hello to the worms. How beautiful these anemones are. Oh, so pretty. Doing their thing.
All right.
Really? That was my 30 seconds. Okay, Adam, we can stow it.
I'll try to get it in. The problem is that when we pushed it down, it's very fluffy. So
Mhm. Yes.
We're,
Yeah.
We're
expecting
we're
that.
aware.
I know. We've
I-
lowered our expectations
Mhm.
of successful capture.
But it's a successful sample because the film turned dark.
Man,
Expectation management.
That's
This
right.
is called.
So I mean that's data right there.
I'm counting on the microbes to be stick. Get in there.
We'll try with a
Get in there. He's going fast. He's going fast. Do we think we lost the whole thing? I don't think so. But yeah. Okay. Okay. All right. Okay. Okay. Do any of the polycarbonates have sulfide film on them?
Number one.
Okay. All right. All right, fell out. Yeah, I expect him to be snottier than that. Okay. Do your polycarbonate course?
Yeah.
So Manette and I are peeling away at 10:30
All
for
right.
ship to shore, so
Yep.
you'll need to
Yeah, Serge is here and I can keep doing this.
Okay.
So I'm not taking anywhere else.
Okay. Since I'm gonna do the ship to shore. Slurping some of the paralvanellids. They were in much better shape when they were cored, so if you wanted to core over them, but
Okay.
these two got blown over, so I actually don't see them.
Yeah.
And I think slurping in the bacterial mat,
Okay.
and then indexing, and then slurping in a bush.
Okay. 2 slurps.
2 slurps.
You want to send? You can.
I'll send Greg in. Yeah,
Send
yeah.
him in.
Okay. All right.
Okay. Yeah.
Allergic to bacterial matter.
What's that?
I'm allergic to bacterial matter.
You can't be allergic. Through the video screen?
Oh, okay.
Yep. All right, so for those of you maybe just joining, we are surprisingly we're just up halfway up the chimney, or about 3/4 of the way up, and there's this ponding sediment or flock that's on a flat area, and so we were trying to capture some data. This is kind of more of a rare occurrence to find ponding sediment in these environments, and it's likely mostly microbial with some hydrothermal minerals mixed in.
Yes.
We just
You can
deployed
see it.
a
On the right-hand
push
on the
core
right-hand
that
side,
has
saw it wobble just then.
black and white film on the
And the,
outside that has a silver emulsion in it, and that silver reacts with the hydrogen sulfide in the sediments, and it gives us a really nice spatial indicator of where sulfide is distributed in the sediment column, and we can use imaging mass spectrometry to get basically a 2D profile of sulfur isotopes of this hydrogen sulfide with increasing depth in the core. So we've been using these in a variety of different types of reducing environments, anywhere from methane cold seeps to vent systems, and so we wanted to compare what the isotope structure might look like up here in this ponding sediment relative to what we see in the surrounding area.
So you want to take a polycarbonate one now?
Yes, please. So maybe can we do number 3? Yep. Yeah, so if people are interested in learning more about this sulfide method, this is something we published a while ago now in 2008, and this was work done by a postdoc in my group at the time, David Fike. If we can, maybe we'll try to post a link to that somewhere, but it's really a nice addition to the geochemical tool set to try to understand how microbes are influencing the sulfur cycle in these environments at the microscale that's more relevant for the types of microbial processes that are happening at the sub millimeter scale.
Back in. I guess it's like a straight right over there.
Yes. All right. So we'll try to be like a cat. Capture it, put it back in. Reflex.
Different.
Oh, into.
Stand off.
Well, if that's the case, we'll go with one. Two's the best chance to get that in there.
Is one better?
One
Just-
has
just
the-
easier.
To the,
Okay.
It has the
That's the one.
Tape
That's
on
the
it.
other.
So
one,
it has
the
the
other.
film on it.
okay, never mind.
Yeah,
We'll go with
yeah, that, yeah. Okay.
3 better than 2.
two's kind of a pain
Okay.
whenever you're in
Yeah.
a hurry.
Got it.
Okay.
That might just be me.
All right.
No, you know.
My fault.
Yep. In terms of the publications on the microbiology of this site, we have a couple of papers that are in the works right now. One of them is available on bioarchives right now, and it's going through second review. And that's sort of a nice description of all of the microbiology in this area and how it relates to another sedimented hydrothermal vent site to the north in Guaymas Basin. Okay, so let's.
Victoria,
Yep, I'm
do you
trying.
want to try it maybe instead of coring kind of straight down, kind of coming back at an angle towards us, but still into the sediment, try to get kind of core in there?
Yeah, see if you can jam it in there. Yes, let's try it.
So just kind of have a slight angle towards us.
Yep. Do you need me to zoom in? No, do it. You got it.
Yeah, you can hear it anywhere. 25. That's what you got. That's all we got there.
Mm.
You want to try a different one?
You could,
Look-
yeah,
look at a different location?
yeah, go ahead. Or you could do multiple punches if that helps.
I like it over in here. It looks deeper next to the two rooms. It's fluffier and deeper.
Back here.
Yeah, right in here, I think.
Can you reach that, Adam?
That
Or-
one was pretty far. It was just beyond the edge of the reach of the last one.
Okay.
If we could bump up a little bit.
Hold on, let's see if I
Yeah.
can.
Huh?
I'm gonna try to bring it into some sight. Alright. Back. Just a little bit more.
Around right there.
There you go, maybe another few inches. Yeah, it's hard.
That's hard.
You found the one spot with the temperature probe.
We can try a little lower here, kind of in this little
Yeah.
valley.
Yeah,
Alright.
that's what works with
Right back
the
down.
probe.
Okay, so I'm not sure.
Is it okay with this angle?
Yep. That's good.
Okay,
All right.
here we go.
Yeah, it's going in.
Alright, I'm coming up.
Rail that was slow.
Yeah. Alright. Pretty far out, but up if I can.
If you do multiple stabs, do you think you can?
Yeah, if you want, I'm happy to like kind of jam
That's
it in there. if you
that's
want.
fine. Just then we can get at least a sample of what the material is, even if we lose the
So just one after
the resolution. Yeah.
Yeah.
Yep.
Stab, stab, stab.
Yep.
Dark there.
Yes.
Sorry.
Yep.
That
Walking psycho maybe?
sounded.
Yeah.
It's really hard right there.
Uh-huh.
How about poke, poke, poke?
Poke,
Is that
poke,
better?
poke. Yes.
It's already long there now.
Sure. Let's do it. But there's anemones attached there, so it makes me feel like there's got to be a hard substrate they're attached to. Could be wrong. Maybe it's a tube worm they're attached to. Oh. Ah. All right.
Are you interested in like layering of it? Or just
Not
that?
anymore right now.
So
Yeah.
you keep it such a separate?
It gets a little too dilute. Yeah.
Oh, you going back in?
Yeah, they're gonna
Pokey, pokey, pokey.
Pokey, keep pokey pokey.
in the back.
So you're witnessing some of the challenges of push coring. So we have to find this happy medium between having enough soft material to actually penetrate and but have it hold enough cohesiveness that it stays in the push core, so we can actually collect it. And so this stuff is really fine and not very deep, so we're having a hard time getting enough of it jammed into the sediment core to collect.
Things I don't know if I can get much. Only if I can- Victoria,
Yeah.
do you want to try kind of
Coming from the
scooping,
below,
like
the
just
scoop,
scooping it basically,
and then what?
and then hopefully holding it.
Yeah, it's kind of like maybe.
Yeah,
It's so fine that
Yeah,
we
yeah.
should just.
I mean we could try. Let's.
Or we could, before we destroy the map, you want to slurp it?
You can scoop it and then pour it into a
Quiver?
quiver.
Yeah.
Yeah, because if it's so fine and we put it in the core, it's just going to flow out the vents.
Yeah. How about I like the idea of the quiver. The slurp is a little bit more. It's harder
Scoop
for us to
into
work
the
with.
quiver.
Yeah.
Yeah, we can do that.
Okay.
Yeah. Alright, do you want to use
Alright.
this to do it, or you want to use
We'll probably use this. Put it into the quiver.
Alright.
I think you should
Take the top one.
well, what I can do is I can redraft this. So it should-
Alright.
So use it as a scoop, and then once I get it out, we're just gonna hold it, and then you can torch out both the quiver and then
Yes.
Alright.
that works. Try it.
Put it back in, there you go.
Yeah, see what. See what. Yeah, it's be better if I do that.
Or do alarm it.
All right, we're gonna try a different technique.
Just gonna have to re-grab it.
I think we're going this. Hold this one here.
Uh-huh.
Wrap it with the other arm.
Yeah.
That's it.
Alright. What should I just touch? Are any of the quivers used?
Nope.
No? Alright.
All quivers are open.
Should I go with
Open and available. Quiver number 7.
Alright.
I'm going to answer it, and then I'll show you.
I got fading in. We're not interested in when he's grabbing it, I always make sure we don't touch the valve ring at the top.
Oh, yeah.
Since we're not really going to suctioning it, it doesn't matter. do a little bit on the top. There you go.
All right. Some good manipulating there. All right, so we're going to try to use the push core as a little scraper. See if we can capture some of this sediment, and we'll put it into one of our bio quivers in the front that we just opened up. And we'll hopefully see how this goes. Hopefully better than the xenophyophores yesterday.
They were
They were okay.
a little mushy.
Things on the white mat.
Any of this sediment. So whatever's an easy angle for you to scoop is good. Some shimmery water coming out underneath there.
Yeah.
A little vent.
That's sticky. That's like
Well, now it sticks.
Now it won't come
What
out.
the hell?
Let's try to dump this before it falls.
Okay.
Yeah.
Falls too far.
Yeah.
Push it up. Yeah.
Oy. Maybe you could try a push core there.
I was wondering that.
Yeah. Once you liberate.
Yeah. Let's report this in the quiver.
Where's that one? Yeah. Right, you're right above it.
Let's name this one Q7.
Yeah.
I'm gonna call this Q7.
Worms too. I just think if you core there, you won't be able to reach the soft core.
Maybe we do like a dry run here with it, make sure we can.
It's quite a bit. Come down with your shoulder.
Almost.
Well, I could bring it in, and you could come across this one.
All right.
Watch.
We don't usually pour this far.
So we're trying to see if we can get enough reach with the
I tried that.
Starboard arm,
Alright,
big.
you have to do that. Sorry.
reach the core rack if we actually are successful at getting a core, or if we have to switch manipulator arms.
Come inboard and screw up. Like that. So,
Yeah, right against you, saying that.
oh, you have pretty clearance. You get, yeah, you can come in, you can smooth left a little bit more, and then straighten that out. You can touch more. Might be the tape.
Wow, that's interesting. I think also if you came in a little bit on the rail.
I can do that.
But let's do some scooping first and come back to that.
Alright. So, 4G. 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 4
some of the spots are super deep and there's some like that.
Yeah,
You can see that's all the station now, so it's not there.
Oh, okay. Alright. Driving me off.
Okay.
Wouldn't be a bad thing actually move closer to
Hmm?
Alright.
Okay.
The rest is just kind of
Yeah, we can just shake the rest out, and then try for a core, and then we'll call it as enough of an effort.
Working in.
Yep. Yep. So normally we don't use the push cores in these ways. Yeah.
kind of off to the right there. Oh yeah, I see it there. Just one
You
candle.
got it? Yeah. Yep.
Before you do that, just rotate your job so it's alright. Just make sure you just watch the top of that. Watch it.
Yeah, I'm hitting again.
Okay.
However, let's do this.
Put it in the
Save
quiver.
that for you. I'll dump that in the
Yeah, we just put it in the quiver, and then should give us at least enough of an idea of what the material is like.
Yeah, so we can save some sediment for chemical analysis as
Yeah.
well as the biological
Yeah.
ones.
That will definitely not be a full chemical workup.
Gonna work out the layers
Yeah.
of the quiver.
Right. Okay.
I
Thank
don't think
you.
We'll get a tour there.
Yeah, it's fine. Yeah. It was a valiant effort. So, and we have some material to work with and a nice sulfide profile, so it's good.
Yeah, let's try this.
Okay.
Um,
And then unfortunately,
Yeah, fortunately, they just like maybe 5-6 inches of rain.
in or out?
Yeah.
Alright, I'll watch your, I have a really good view of the porch here.
Are these anemones or parahalmonels? I'm not sure.
those are anemones.
Okay.
But there was
I
some.
bet if you bump up, you can find some.
That's
Yeah,
an
so-
parahalmonel in there. Yeah.
You come left.
Yeah.
Yeah, Shauna wants some
And you come
slurping,
left
so
or you go
Yeah.
straight.
That's
she wanted one in the mat and then one under the two-burn bush, so we'll do that first.
Yep.
Yeah.
Things you learn.
Wow. When do we do that?
I don't think you don't know if you agree here. I don't think
Yeah.
Okay, if you just look there.
Alright.
Yes, collecting sediment in a core quiver is not usually our preferred way of analyzing this material, but some material is better than no material, so we often have to sort of decide on the fly how we want to collect samples, and this is a compromise here. We at least have some of the sediment material. We can begin to look at the chemical composition, the mineralogy, and potentially look at some of the microorganisms associated with it, depending on what it looks like when it comes up. Nope. So we're currently at a place called P Vent. This is to the north of Z Vent that we had dove on two dives ago. And I personally have never visited this particular site. The last time Dr. Z has been here was in 2017, and the last time there was extensive work done, I think, was in 2015, where they were able to do some measurements of the hydrothermal fluids. And the system has changed quite a bit since that initial dive. Some of our shore-based scientists were able to send us some of the photos from that 2015 dive, so we've been able to sort of compare side by side in 2015. And definitely the plumbing has shifted around. There's different areas of high venting activity and other places that we no longer recognize that were quite iconic in 2015.
Take that.
Alright, this guy right here before you go away. No. We got one more job to do first.
Oh, that one? This?
We're
No, but we gotta put the cap of
Yeah.
the other one on there.
We'll
And
do
then,
the start around.
okay.
No, you're right. You're right.
we didn't rack 6 up.
Well, we can't. Yeah, I don't see it floating. I don't even see the green. Well, we we let our Swiss chalet. What's that?
Do we need to rack it now, or can we try it when we do push core 5 later?
Yeah, we can do that later. Yeah.
Let's,
Sure.
yeah, rather than messing with it now.
The good thing is that one's the aluminum one, so it's quite a bit
Yeah,
heavier.
yeah.
But when we draped it over, forged in, and I don't know if it broke off and fell down on the inside or the outside. It's
Yep.
MIA there.
Okay. All right.
Maybe it's hiding under the house.
Yep.
Maybe when we pull the house out, we'll find it.
Yeah. Okay, so we're gonna do some slurping now.
Here?
Yes.
Okay.
Yep. So, and J-Rod got me a really nice marine snow sample in one, and so we're the goal is to not index
Yeah.
across one at all. So go the other way around.
We're on 3 right now. Do we have something in 2?
There is
Yes.
something
Okay.
in 2.
One and
Yeah.
2
So
can be
so 3 is ready to roll.
Outstanding.
Yep.
Yeah.
Yep. Is that gonna help you? What you know? Yeah, it's off. Yeah. You're on your own. Thanks for that. You know me, when it gets tough, I roll out.
All right, so we're going to use the suction sampler to collect some of the hidden critters that live within the microbial mats here at P-Vent, and then we'll also try to do a second slurp within the tube worm bushes themselves. So
What would you like?
let's start with the microbial mat.
Greg will be in a minute.
Okay, so let's try, let me see, there was some, so do you see this para-alvanellid here? Is that too far?
Grab out. I can try to.
There, I think there might be another one here too. Let's see. Oop.
I think pretty much all
No,
that
it's a nosis, yeah.
forward side of the vehicle, so it might. Is there if there's anything on the starboard side, we can do that
Okay.
first, and then I can move over for the port, or is everything going?
All right, let me take a look. I mean, you probably could do within these tube worm bushes.
Yeah.
So, bare albanels right there.
Oh yeah, I see. Okay, so maybe why don't we try this sediment patch here? Because Eagle Eye Dr. Z has found our para-alvanellids.
Could you get a zoom in?
Yep.
Paralvanella bactericola.
Bactericola?
Yep.
Ah.
First described from Guaymas. Not because of any association with bacteria, but that it seemed to like bacterial mats to live in.
Okay. Staying true to its
Yeah, we got.
name.
We got. Well, we told them from
The little brown threads are another polychaete that likes bacteria called a Dovaleid,
Yeah.
and that's everywhere. Must be the most abundant animal here.
Depending on what we have. Depending on what we have.
So some nice hydrothermal fluid coming out.
These little red worms are not Victoria's worms. They're another one called. It's a new species, Branchionota glumma. It's species 4, we're calling it, so we can get around to giving it a name.
Huh. Which ones are you looking at?
The cockroachy ones, all of those.
Ah,
Yeah, just that patch
totally
where
thought
the,
that was Penile polynoi.
Yeah, I don't see any here. I think these are all the other
Ah.
kind.
Interesting. All right. Are we ready to slurp? Or-
we have to get some maneuvering stuff set up.
Okay. Yeah, I don't know. I thought it would be good to get. It's
Point where you're looking there exactly.
okay. 1 sec.
It's bacteria.
Yeah. We could get that in a second slurp. So it was over. Where did you want to do it, Greg?
Yeah, one sediment, that sediment patch, and then
So right in, right to the right of the handle that you're seeing. Do you see those between the monkey fist and the handle?
I'm gonna push it first thing. Okay, we just need that more reach and bring it in.
The monkey fist. Thought we got away from it.
Your waiting stick there.
All in here. Especially these guys. I think, right? Do you want more examples of the
yeah,
Auka albanelids?
To hopefully we'll see if they
Alright,
live.
work out some.
Yeah.
It's good the ones you had at the top of the push cord were alive. I ended up freezing those.
Really?
They were perfectly happy.
I did a little bit, and it started to stop the thing. So I think
Yeah,
that
if this was
started-
horrible, we could do
that's
that.
supposed
Yeah,
They should have a slurp. Should bring
Yeah.
another can.
Yeah. Alright, let me try it. Stand by. Hold on.
This will be as
Yeah, it's not on, so it's not going to be. This starboard or port?
Does it smell like this?
Okay, so that'll be equal. Okay.
It's in the library too. Somewhere up there. Hold on.
at the D at the end. Did I do it this way? Pear, Alvin, Ella. No.
Try it now.
Okay.
Stand by. Get back.
All right, we're just getting in position to do some suction sampling or slurping.
I'll go to the port channel a little bit. Yeah, come back in. Yeah, so I'm gonna fly it a little bit when we do it. That's not a problem. Yeah.
Fumes.
Well, not what I can do about that. If I force you anything too far, so I might have to just come off and
All right.
Alright, bring it back.
Well, we enjoy sharing our science with you all at home as well. You're asking great questions. I don't know about whether or not there are any deep sea organisms that also follow the moon in terms of their reproductive cycle. I've never heard of any, but I'm also the microbiologist on board, so I may not be the most equipped to be able to answer that question.
Sorry about that.
It's a little messy.
I don't dig around in it.
Mm. Okay.
No.
Here's one of yours.
Oh yeah.
They're much bigger.
Yeah, if you hadn't said that, I wouldn't have known they were different.
I started figuring out I want to get a few more because now we weren't able to tell the sexes apart.
Just barely.
Of
Which is unusual.
Panelate polynily or
Of panelate polynomial.
yeah.
But I just had that on the other night and we now can.
Oh great.
With another paper.
We are still
Amazing. Okay.
we're still far away.
Yeah, there's lots.
Yeah. At least 3.
Yeah, here too.
Mm-hmm.
Yeah. I'm not sure what it's going to do, but we'll give it a shot.
Yeah, when you see them side by side, you can tell. They're like,
No, I didn't.
Yours has less scales.
But
That was our first clue.
They
Less
called
pairs.
up
Yours
one
has
when
9
I
pairs of scales. These have 10 or 11.
and not rotating much. I had a poor result for us.
all right.
Alright, that's all I got.
Okay.
So let's see where you're going.
Commencing slurping. And all right, so you can see in this field of view, there's quite a bit of diversity of invertebrates. My colleague Greg Rouse is here. He's identified at least 2 different species of scale worms, the ones that we're slurping right now. Red scale worm, that's, what do we call this one?
We're calling it Brachynotogluma right now. Number 4. My student Avery back in San Diego is doing a big project on scale worms. And we're going to end up naming Brachynotogluma in a bunch of different groups. But this one is one of our favorite Brachynotoglummas. Look how abundant it is here, especially on the left of the screen. All those red little cockroachy creatures.
Watch out for you.
But what we also want here are the little palm worms.
Number 3? Yeah.
Spin
think
you
so.
around. Spin you around.
The little feathery
Yeah.
worms coming out of the sediment, and they're another group quite famous as palm worms or Pompeii worms for tolerating hot water. This one's called Paravanella bactericola, first described from Guaymas Basin, a little bit 400 kilometers north of where we are now, with some sedimented vents. Adam, if you could come down a little bit onto
Yeah,
the sediment.
not the 2 worms.
Yeah, I spun him into that so we can get closer. Yeah, sorry. Alright, that section's off, so.
Yeah.
Okay. Yeah.
the little feathery guys coming out of the sediment.
You see it below?
Alright, now I'm going to be able to work. I'm going to come out on the rail a little bit, give you a better view.
Yeah.
That's it.
Yep. There.
Alright. And hold on.
Welcome, Florian. Nice to see you. We'll try to get more heat flow measurements for you for sure. Especially if you analyze them real time and tell us what they all mean. So Florian was sailing on the second leg. We're currently doing the third leg of this three-part expedition to Pescadero Basin. And this leg here is focused much more on the biology, and it's building on the information that was obtained from the mapping leg and the folks that were doing heat flow measurements to learn more about the geology and the geological history of this basin and these vent systems.
That's great. Okay. That's
Okay.
good.
Happy here?
That's
Yes.
great.
Alright.
I'm gonna shake it out or shake it in. Do you want to index and get in the tube worms too?
Yeah.
Yep. Can we get
Do you
that?
wanna get the
snot?
bacteria?
Yeah. Okay.
Alright.
Can we index to 4?
Alright.
And
Alright. We're off.
okay. Can you reach this bacterial flock over here? Maybe we'll slurp in and around that.
Just get them to poke in and around.
Mm-hmm.
Yes.
Yep.
That's disturbing.
Do you want him to move around in there?
Stay together as clumps.
Yeah, it would be great. Yeah. Can you could you try to capture one of the tube worms that has that bacterial flock on it? I don't know if you.
That one right.
Yeah, exactly.
Those?
Yep.
One of those with all the
So
stuff on
crazy.
the worm pouches.
What is that?
The marina worms are all
Yes.
over this.
Yeah.
Ready? Yeah. Go on.
So we have 8 discrete slurp canisters on board that allow us to capture discrete samples. And they're on a rotating system. And so there's a separate camera that we can see that shows us the canister so we can watch the material we're slurping on the seafloor and make sure it actually ends up in the canister on board. Okay, I think that's good. Thank you.
Alright, it's off. Alright, and when you
Shake that out.
we're on 5 now.
number 5.
It's almost out.
Are you gonna want slurps from other areas?
And
in
a push
here?
corny mats.
We are when we go to over by Z-Vent.
Then I would push corny
Okay.
mats like that.
Do you want me to have them put it on 8 and pull through so you're not getting a mix? While we're cruising around, could we index to 8, but not 1, and just suck to see if we can clear some of the tube worm debris out? Oh yeah, great. They're showing an image of the camera on the slurp containers. Great. All right,
That's pretty clear.
that looks good. Yeah.
Alright.
Wonderful. Okay. So Z, you want to get a rock sample from up here? Do you wanna,
Great.
Any thoughts? Plans?
I don't see anything very
Chimney.
grammable right here, except
Yeah.
that little ledge there, but it's gonna be pretty crumbly.
Yeah.
I think we'd have to move.
Okay.
I'm not critical for a rock sample unless you want one.
Okay. I think we would like to have a representative from here, so. All right, we're gonna move and see if we can collect a rock sample.
Do you want an old chimney or do you want something more solid?
I would like maybe one of each.
Okay, look good. Those old
Yeah.
chimneys probably are not too weathered.
Okay.
They look like they could be grabbable.
Yeah.
It is
Kind of nice if we could
inside
lateral around to the right, get a view back with those chimneys,
Yeah.
with the worm bushes to the left of us,
Okay.
because I think that matches some of the views I was just looking at.
Yep. Yep.
Okay.
From Jenny.
Yeah.
We're gonna bring in the port arm a little bit more.
Okay.
Alright, so we'll get rocks from one of those.
Nice to see you, Avery. We got you some good samples. So Avery, this is that other scale worm, the little red one, species number 4. All right, so if we can go out to the right here and get a view, I think we might want to try to collect those chimneys. I don't know if it's possible to maneuver to get them, but we want to first come to the right and get an image of the system, because we have the images from 2015 and we think that that's sort of the right orientation.
My only concern with doing this right now is that it's gonna put a turn in my tether if I do too much further.
Oh.
Can I come out to the left all the way around?
Okay.
Is that alright? It's not too big, is it?
No, you can
Okay.
you could do that.
Okay, look
Yeah.
to the left there.
Get another view of this place called P Vent.
No, we just got that. Yeah, we didn't get anything with it. Other than learn that we could do it with the starboard arm.
Yeah.
Which is kind of like science experiments.
So a lot of the tube worms at the top of this mound here don't have their plumes out. They don't look very happy. there are areas around to the side where we have pretty dense clusters. Worms. And the really neat thing is you see these bright white patches in and amongst the tube worms, and this is a microbial mat that's colonizing on the tube worm tubes. And if we zoom in closely, we'll see that these are localized areas of hydrothermal venting. So we can use the bacterial mats kind of as nice indicators for where the localized fluid flow is coming out. I think that's
Tube bone push to the right, maybe? I don't know.
yeah, that could be.
A bit lower in this
Yeah.
picture. Yeah. So,
Is that what we were looking at earlier?
Hmm?
What we were looking at earlier?
What were we looking at? This.
Sorry, back. Was it further down? Because I thought it was like 3 or 4 or something like that.
Are you talking about the little spider things? Oh yeah, they think they're down or on the
Okay.
other side. Yeah, this is a different one. Hmm.
Previous cause
Yeah.
wouldn't retry, maybe. Yeah, it looked like it was.
So it was just cause something.
Hmm. Did we bump something?
No, that was below me. I didn't realize it.
Oh,
Last
okay.
second, so before I did it, I didn't bump it.
Yeah. Maybe we can.
Affected it.
So that we.
Moved to the right. I just want to be clear this before I go back in because that thing sticks out pretty far.
Yeah. All right. It's a winter wonderland down here. All microbial flock in the water column. For me, this is the best type of winterscape here, all made of microorganisms.
This great field is here. It's supposed to be here, but it's what it is. So if you put house out, it might pop out, but I can't see it anymore. This guy's still open, just if you put them out, just give them a shade. The bungee was loose green, it's not cut up, it's tight again, so it should be good. Just send it.
3, 4, 5.
3, 4, 5, yeah. So just 6, 7, and 8 basically. And 8 is flush.
Yep.
And then 9, you get section.
Yeah, section was in the hand. Thought it was. It's dark, but it seems to be fine. I'll be back.
Yeah. Search and what is
What are we going to do now?
yes.
Look at the piece.
Is it on the
said he's getting called.
We should have him translate in Spanish. But I want to see if we can get this headset working.
Alright.
Maybe.
This one.
This is what you want to
Yeah,
do,
that
right?
could be it.
This is the lower.
So it looks
the
like
lower
it's more.
flange.
So it looks like more active here. That's
Yeah.
really that spine here.
Yeah.
So you want to grab?
Valerie, can we zoom on that chimney on the side of the flange? See if it's active, see the one.
Yeah, see.
Because I think we just set up a sample out of exactly that guy right there.
You want to do that?
He's not very active. He looks fun.
Yeah.
Okay, never mind. Thanks.
So we're gonna do Z.
Yeah, I think C's a better shot.
Okay.
Alright. So,
So what do we think about this? We should keep going around. I don't want us to destroy this one.
Yeah.
There's some in the distance. I think that's where we were, right?
Yeah, the
Over
distance.
there.
The ones around the corner are the ones
Yeah.
that I was thinking of. Yeah, this is.
Yeah.
Yeah, and then those.
So maybe we can see if we can
This little village.
collect one of these little chimneys.
That's the broken edge of the flange that came off. You might be able to get a flange and a chimney in the same place there.
Right here. Yeah.
Yeah.
Is that a possibility, folks?
Yeah.
Yeah.
went up in there.
Yeah.
Alright.
It's a beautiful sample.
We're on the right hand side, right? Or do you want to be able to access off of all of them?
Oh, we want to get
Oh, right there?
this guy's
Okay.
here because there's a.
Yeah.
Z thinks it's a piece of
fallen
flange.
chimney.
Oh,
That's
it's a fallen chimney.
cluster.
That's not flange. Is there a better spot that you think?
No, I think going for those chimneys right in front of you, I think that one
Okay.
looks kind of solid. I think it might be a pretty good
Yeah,
grab.
this guy right here.
You want that slab, right?
Yes, the little chimney, the wider one, if we can. Yeah.
What's that?
Stay with the rocket.
I'll go out there.
Take it a shot.
Push it through instead of push down.
So that looks good. You able to get into it? Yeah.
All right. So we're still trying to get a good shot of this. The white balance a little off here.
Ship to shore incoming.
But that's on the flange right there when they get through. Right?
Okay. Yeah, not gonna. So we could go down.
No suction sampling is thrown for there.
No section sampling, just grabbing rocks. Yeah, thanks.
Alright, so going for that white chimney.
Yes, please.
Don't take that long. Sit up.
It has provonids on it.
I'll sit down a little bit.
The other one looks like it's venting.
There's some nice castor pots on there. Big
Do
castor
you want
pots.
Yes. Yes, I am currently trying to sample this chimney. This, I'm guessing it's a dormer chimney, is that correct?
I don't know. The one next to it is venting.
This is, yeah, it's certainly this collection of them is, I don't know exactly which one is which, but I think these are either one of these or the ones to the left of these are these. But this is the separate feature.
All right.
But yeah, this whole thing.
Sometimes it's easy. Right now, this one's a little difficult because I haven't had very good success with these chimneys not crumbling at the bottom.
We're gonna. That's good. Oh. Winner, winner.
Whoa!
Okay.
I would like to get it over.
Let's get it. Let's just in a bio box. We don't. That's a nice sample. Yeah. Three, any of the three. All right. Expert grab by J-Rod, one of our pilots here with Chris.
All right, y'all haven't marked 3A yet, right?
We haven't put
Yeah,
any.
there's nothing
yeah, there's
anywhere.
nothing in the bio
I'm
boxes.
hanging
So
over 3A, but I'm going to try to rotate it ever so slightly to 3B.
okay.
If I can put it in gently instead of dropping it from high.
Yep, that would be
That makes
lovely.
sense. Come on, draw a truck.
Yeah.
Put it in the clamps.
All right. Most of these samples that we've been collecting this cruise have been quite fragile. So it was definitely a fortuitous grab here that J-Rod was able to break it off so cleanly with the manipulator arm. A lot of the earlier attempts, everything would crumble when we tried to grab it with the manip. Yep.
Go to power box like this.
Yeah. Yep. Yeah, we might have another showcase of UV lit fluorescence on these samples. It's some future dive date. We've been collecting them. Nice. Beautiful, beautiful. Fantastic. Okay.
And I think just below
Can
the
I-
porch, there's a small flange that is probably a pretty good grab.
Yep.
Just about
Let me just
half a meter down
let me
below us.
let me just zoom in on here real quick so I can capture the context. I also wanted to see if there was any fluid coming out, because the other one was definitely, yeah, that's great, J-Rod, thanks. So you can see a little bit of shimmering just there. And yeah, I can't tell if it's coming from behind it, but this one definitely has
Dorvalades.
denting it. Well, you see all the shimmering? All right.
The area is active, whether the chimney
Great.
itself.
Okay, so where did you think? Yeah.
It's just below the porch.
Okay.
Looking looking right there. You see it
Yep.
in front of the trigger of the
Yep.
cast tight. I think that is a little flange.
Can we capture it with here? Let's see.
Although I'm not sure there's anywhere to
It's
land
right
to
there.
grab it.
Right
Yeah,
there?
That's it.
Okay. So J-Rod, what do you think about that? Yeah, this flange down here. That'd be lovely.
That whole side?
The holes, as much as the slab as you can get.
You're all right. Honestly, that gas tank, that should be the whole.
Yep, I got a computer right here.
Hmm. Yep.
Totally clear. Plenty of space on the gas pipe.
So
Rest of the porch.
on the top of that chimney that was to the left of the one we collected, those were all Dorvalid polychaetes. These Dorvalids are among some of the champions for sulfide tolerance. One of my colleagues at Scripps has been studying these organisms, or the group of Dorvalids, and has been using isotopic techniques to try to understand what they're eating in methane-rich environments. And so we don't know much about the Dorvalids in this particular habitat here in terms of their ecology, but they're one of the more abundant organisms that we're finding at these vent sites.
Set the cool off a little bit.
Have fun. I might keep going around. But that's it.
Oh, wow, that's beautiful though.
That's it.
Okay. Yep.
Yeah, it is.
So we're trying to be a little strategic with our mineral collections. Not all rocks are created equal, and so we're trying to collect different types of these hydrothermal edifices. So some look like chimneys, and these are the direct conduits where hydrothermal fluid is being focused. And in other places, we're looking at flanges, which are sort of laterally projecting features where hydrothermal fluids pond underneath them, and they create that mirror-like image that we've seen in some of the earlier dives. So the sample we're collecting now, we think is part of a flange, and we'll be able to compare that to the hydrothermal chimney that we just collected to look at not only the types of minerals that are there, but the spatial orientation of those minerals relative to where hydrothermal fluid is venting. your breath.
You got it Alright, stay lined up, stay put. We're off.
Can you come down just a touch?
Yep.
It's a really nice view into the chimney.
Yeah, I know. I didn't want to take the camera though while they're.
Yeah.
We can do it before we leave this site. We can zoom in on it before we leave this area. Somebody was asking if we knew how old this system are.
I think this is active in 2017, 2050.
No, but like how old, like when did it form?
So I knew that. I'm thinking these things are maybe 10,000 years old. And I can't avoid improvement. I think they're old, but they're so big they have to be old because they're growing fast. But that's really unquantified.
Do you wanna talk a little bit about that?
Yeah, you say that.
All right.
Yeah, it's an important question we can't answer yet.
Yep. Somebody asked a very important question about the age of these hydrothermal systems, and that is sort of one of the outstanding questions that the science team, both the ones on the ship now and also those that are from our shore-based community, are trying to understand. So we can use things like the size of the hydrothermal vent edifices and the potential rates of mineral accretion to give us some general estimates. Dr. Z, who is our resident geologist on board here, was saying his estimate is they could be tens of thousands of years old, but really that's just a guess. So there are other techniques like stable isotope methods that we can use for dating.
Try with the cork north of the bottom there.
Yeah, it's gonna be tight. Like with this one, yeah. You're gonna come over. Or you think you know, or like, get it on top of the board.
That's amazing. Wow, J-Rod. Oh.
Alright, four shot. We gonna put it before?
Yeah, it seems like 4 is a good. Oh.
I'm scared.
Ah. Did it go down? That little modest piece. All right, we're gonna go for something a little more bite size.
Hold on. Yes.
All right. Might not be our day for flanges.
Clams?
You got about
Yeah.
8 inches.
Yeah.
I know, my favorite, clam scoop.
4 inches. Alright, I'll stop right there. Okay, you're after it. You just might hit the. Get some more space before you get to the.
Come on.
Alright, we need to pull it out to get more space. Shove.
Yeah, y'all want that one or do y'all want to drop down?
This is fine if you can.
Alright,
Yeah, I think that's neat. You grab that one. That one's
Yeah.
fine. That's a good piece.
But the big one was still awesome.
The other one was definitely awesome, but hard.
I'm gonna come back down and put a little bit further to the left so there's more space.
Mm.
What's that?
Keep going. Yeah, I'll probably use some of that. Soft crust. It's gonna come in more to the left, huh?
I can just I'll hit up on some worms. I go a little bit and then rotate first. Put it down.
Yeah, it's like that.
Alright. Oh, that's closer than I thought.
I know, it's beautiful.
Yeah, you're way up. You got plenty of space.
All those moments.
That's a nice one. Beauty.
He just missed that first desk. Since he just missed that first desk.
Oh.
All right, this is going in.
You could put it in the other compartment, 3A. Yeah.
What's that?
Is this the flange piece?
This is a piece of the flange. Yeah.
About 3.
All right. Nice sample.
Perfect. Great.
Great. Amazing. Okay. You good?
Yeah. You want to fly over to the Z?
Yep.
You
Well-
want to get lunch and I'll take us over there
Okay.
if you're through here.
Yep.
Okay.
And we want to do, we'll want to do coring north of C, so I don't know if I want to do that first.
I think, why don't we try and just get the sampling done during lunch? The water bottles. And then we
Yeah.
drop down. Does that, if that works for you?
Yeah. Did you eat already?
No, I'm not going to eat.
No.
I'm not going to eat.
Okay.
Good.
All right. We'll want to fire a couple of Niskin bottles.
Right here?
Maybe we can do it over the
To the right
flow.
where
Yeah.
the flow was.
Yeah. Okay.
Alright.
Yeah. Yeah. Let's see.
Yeah, so I'll try and get the water bottles and then you want to go to which mounds? The ones
Once the north, where we were the first day.
Yeah.
Those mats.
over the,
Yep.
the old novel area.
Yeah.
Yeah, well, all right, good.
Yeah. And we're doing these tests, but if we are going to go to see, fly by and take a look at the colonization zones.
Okay. Yeah,
Where if it's close to the.
yeah. Once we get the water sample,
But,
we can just
yeah.
circle right up.
That's what we want to think.
Circle back, that'll work.
Yeah, but I just want to make sure that we have enough. Yeah.
So you want to be about this to take the Niskins?
Yes, please. Such a nice little spot.
Yeah, it was good snapshot of there.
Yeah.
Fluffy stuff.
The same texture as what we saw last night with the, of course, calcite. So finer calcite.
That's how we did view it on HD2.
Yeah, it's iron oxide. The question is it oxidation with a little bit of sunlight in there, or is it
That's the
like
1 and
stage
2,
ones
right?
or just cold and oxidized? Not sure we can tell. Get it up.
Niskin 1 and 2.
1 and 2.
1 and 2 is fine. Yes. Thank you.
Just touch.
You got one good, Chris?
It's pretty much above that right now.
Okay. We're going to collect some water samples here, just above the beautiful white
One
spires of
fire?
P-vent.
1,
This
2.
gives us a discrete water sample, 5 liters in each bottle, that we'll use for some of our incubation experiments.
2 fire.
Usually look at the microbial communities in
Roger
in
that.
the water.
Okay, so big flange on Z. If you remember, we had a little place set up on the north side of the flange. So here's a question here. Do you want to bring up the temperature for before we get there?
How far away? Yeah, I guess we can start working on that.
Yes. So up to you. We're going to be that big plant to sit down. We're going to be on the north side, so the plant is not over to the south. Should be able to reach out quick. We have a mark. I think so. We mark on that side.
We're just gonna start coming now. It seems pretty high, so I'm gonna come to the port a bit more, and then come in from the northeast. That spot we just at, that vent is fairly high, so keep going to the port and then come in from the northeast. A little higher than that though.
Where are we heading to?
To the Z mound, to the big flange on the Z mound. Okay, so we've just gotten a couple of nice samples. They look very typical of what was sampled at this mound back in 2015. And these chimneys are dominantly made of calcium carbonate, and they have very minor amounts of sulfide in them. Just a little bit of pyrrhotite, iron sulfide, a little bit of chalcopyrite, the copper iron sulfide, and a little bit of zinc sulfide, but the values are very low, and very low silver and gold, almost undetectable. So it was kind of typical of what we see of most of the mounds here. And now we're going to go back to the Z mound. We hope to find a place to sample hydrothermal mount or fluids on the P mound, but they're not a really good place to set down safely where we could reach into the hydrothermal fluid. So we've decided to go back and try and take hydrothermal fluids at the Z mound underneath the big mirror pool flange that we saw earlier in the cruise, if folks were watching. So it's a very spectacular flange, and there was a nice place to set up on the north side of it where we can reach under it but not have the flange overhanging us, which is not a good thing to do.
Gas tight or major?
Either one first. Yeah, I'd go major if you have a choice, but
Yeah, you have a choice.
yeah, let's do major first, and then but I want to do temperature first, then major, then gas tank. So.
I'll see you.
And so the samples that we collected yesterday, which is near the Diane's vent, previous samples had some of the most metal sulfide, chalcopyrite and galena. Did not actually see any galena in the samples we collected yesterday, and in the rocks I looked at, I saw a single crystal of chalcopyrite in the calcite. So I'm sure when we get back and make polished thin sections and look at them in the lab, we'll see very small grains, but not nearly as high in metals as previous samples from that vent, which were just in one little layer actually. So not surprising that we didn't catch that. So we're just getting ready to sample. We're just going to grab the bottles while we're in transit so that we're ready to sample once we get there. So the bottle on the left-hand side of your screen that J-Rod is about to acquire is what we call the major sampler, because we use it for the major elements and the trace elements. It's basically just a big titanium syringe. And the reason we use titanium is because, one, these fluids are very hot and can be corrosive, although the fluids here at Pescadero do not have very high pH. They're just slightly alkaline at temperature. So, when these are used for black smokers, the pHs of those fluids is very acidic, and so we use titanium because it's can both handle the temperature, and it's not easily doesn't have trace elements that contaminate our sample. We want to measure things like copper, lead, and zinc. Some of those elements are in stainless steel, and they would contaminate if we had a stainless steel bottle. So that's why we use the titanium. They were specially designed back in 1978 or 79 for sampling the first black smokers that were found in the East Pacific Rise at 21 degrees north of the East Pacific Rise. And my good friend, former friend who has passed away too young, Karen Von Dam, was the one who was able to sample those vents, and that was her PhD chemistry, the fluid of those. And Karen and I worked together for many years, first at the U.S. Geological Survey. And I was fortunate enough to get some of the sulfide samples from those first chimneys, and they became part of my PhD thesis as well. And as we've said previously, the reason why these vents don't have very much metal, and why they're more alkaline, why they're precipitating calcium carbonate, is because the hot fluids here probably do have the same composition as black smoker fluids in the depth, in the deep sea floor where they're interacting with volcanic rocks. But as they come up, all the volcanic rocks here are buried under sediment, so it's the interaction with the sediment that changes the composition of these fluids. And one of the reasons we're interested in sampling the fluids in the rocks is because we want to know what's in the subsurface, and using the chemistry of the fluids in the rocks, we can infer just exactly what rocks have interacted with the water on the way up. So that's why we want to get these samples.
Do you have a thing you want to come in on?
I'm sorry?
Do you have a direction?
Yeah, we're just going to come in on the west side.
What's that?
I think that dot is isn't that the mark we left?
Probably.
Yeah, well, maybe not, because the chimney's on the west side, a little on the north. It should be very near that dot. I mean, the flange, rather. I think that's the mark we left. That looks just right.
All I have over here marker-wise is snowman chimney and one of the maps. So I don't have anything actually on the.
The first day when we surveyed the big flange, I thought we left a mark.
Yeah.
Maybe.
But anyway, you just find the big flange. It's not hard to find.
Which I just.
Yeah.
In fact, I think just southwest of the hand I think that might be the big flange sticking out right there. No, that's too low down. It's more like right into the red dot, I think.
We'll find.
Yeah, it's a pretty obvious feature. And And those of you who haven't seen this big flange, this mirror pool underneath it, is really a cool feature. Hot fluids are ponding up underneath this flange, which grows out horizontally from the chimney. And as you'll see, we're going to measure the temperature. I expect it to be 298 degrees, but I have been often wrong in my expectations, so that's why we do measurements. But as you'll see, that fluid, hot fluid, is going to be ponded up underneath the flange and in contact with cold seawater underneath with an interface that is so sharp that it acts like a mirror. The refractive index, or the speed of light in water or in air, is a function of temperature. And just like you get mirages and where there's temperature inversions in air, there's a very strong contrast in the speed of light between the hot fluid and the cold fluid. And so that interface acts as a mirror and reflects light. So one of the more spectacular places we've seen in this vent field, and that's where we're going to attempt to do a sample. So in really deep water like we are now, the dissolution of some CO2 from the decay of organic matter makes deep water more acidic than surface waters. And at some depth, calcium carbonate becomes undersaturated. And the depth at which all calcium carbonate shells from surface organisms dissolve is called the calcium carbonate compensation depth. And I don't know exactly where that is here, but we are below it. So in fact, the sediments here don't have calcium carbonate because calcium carbonate is undersaturated. So why do we have these big hydrothermal mounds? Well, they're simply growing faster from the hot fluid than they're dissolving. But as you may have seen in the old dead chimney we just collected, the calcium carbonate was starting to dissolve. So these mounds are building up, but they're also dissolving, and it's a matter of rate, and they're building up faster than they can dissolve away. It has certainly taken a while to make a mound that's 50 meters across and 20 meters high. That's an awful lot of calcium carbonate, and so these things don't grow very fast. I wish I knew exactly how fast they grew and how old these mounds were. It is my guess, and that's all it is, that these mounds are probably on the order of 10,000 years old. But hopefully in the future we'll find a way to get some harder numbers on that. We can do some coring in the surrounding sediments and look for geochemical evidence of the onset of hydrothermal activity here. That's one way to do it. If we get samples from the interior of the mound, there are a few, not easily done, but ways to do some radioactive dating. We can't use carbon-14 because most of the carbon that is coming out of these vents that's building the chimneys is very old carbon from either the crust of the sediments, and it doesn't have any carbon-14 in it. So it's what we call dead carbon. So carbon-14 is made in the upper atmosphere by cosmic rays, and so things that are growing in the surface can pick up carbon-14. But there is essentially no carbon-14 in these deep hydrothermal fluids, and so we can't use that radioactive clock. Yeah, we're coming right across the mound where they cored the other day. We'll probably come back here right after we sample, so this is good to see. Right where we should be, and you're heading right for it. I like this. We're looking good. Okay, now we're coming into the base of the big Z chimney, which is in front of us, and you're seeing big blocks of carbonate talus that have broken off, so these mounds grow up and they're unstable. As they grow, they continually collapse, and this is, you can see how big these blocks are. They're about the size of the submersible. So the mounds are formed by the accumulation of all this chimney and debris, and that's how we built up something as big as this. Clearly it's taken a while, but I wish I could put a good number on that. My 10,000 year number is simply a guess. Could be way off, but I don't think I'm off too much on the younger side. Maybe on the older side, hard to tell. All right, now we're starting to rise up the chimney, and you can see some nice flat slabs of fairly fresh looking carbonate. Those are flanges that have broken off more recently, like the one just toward the top in the right hand side of the screen. That, in fact, that's a flange that is upside down. That was the bottom of the flange, and you can see the sort of, if that were a pool in the hot spring terrace, those would be the riffle marks, but of course here the buoyancy is the other way, the fluids are flowing up. So that's a beautiful view of a recently broken off upside down flange. And we're going to be looking at the bottom side of an active one very shortly here. And there's our target coming up on the other camera that you can't see, but you will see in a minute. The spectacular flange. So we want to be all the way over on the left side of it.
Go look at it first,
Yeah.
and then
Yeah. Okay, and now you're seeing this flange, and you see that reflection. That water, we're about to try and measure the temperature. It's probably 280 degrees, and a couple of millimeters away, you're in 2-degree water. You can see the ripples from where the water is flowing out just next to the chimney, and it flows out. As it flows out above the lip, you can see shimmering water, and that's feeding the tube worms and the chimneys on top of it. So it's quite a beautiful structure with these active tube worms on it. As the hot water flows over the edge, it mixes with seawater. The hot fluid has high calcium, but there's no sulfate or magnesium in the high temperature fluids. They've lost that by reaction with the rock. But when the calcium-rich hot water mixes with sulfate-rich cold water, it forms a mineral anhydrite, and that's how the mounds or the flanges or the chimneys grow out. They start with anhydrite from the mixing zone between the two fluids, but directly underneath the hot water, where there's no mixing, the mineral that is in equilibrium is calcite. So almost everything that is going to be coating the roof of this flange, the other side, will be calcite, and it can be coarse grained, really beautiful crystalline calcite.
alright, so after this, so we can
Yeah, so if we park right over in there, we won't have flange above us, and we should be able to reach in underneath. And there's no hot flow underneath either. We saw that the other day.
Just a
It's going to become a gallon, so that we can see the nozzle go in.
Yeah.
So I want to pour it in. Start coming down.
that sucks.
Right over here, you're good. Yeah, good.
There we go.
Right around here, and we're getting close to that.
Okay, so when we're maneuvering things, we need careful communication. So if we go silent for a bit, it's because I've turned off the mic just to make communications with the pilots and between the pilots much easier. So don't be alarmed if we go silent. We'll come back and talk to you when we get through with this operation. It's looking good.
Look off to the right. Let me see if I'm going to be able to get to this with my 10 Pro. Might have to rotate. I have to look at the central.
Oh,
Very much.
yeah, I don't know.
I should be able to reach that, I think.
Right.
Right. So you're ready to get a temperature probe reading?
Yeah, I'm good if you are. This looks really good to me.
Just look down at that. It's like, might have to go travel.
I can do that.
And do you see the ripple marks?
Yes, sir.
That'd be a perfect place because that's where the fluids come right out.
Okay.
If you can't reach that, don't worry about it, but that would be great.
Alright.
So the probe right now is reading 2.2 degrees centigrade.
Pretty stretched out on that beast over there.
Okay, you can see the temperature on the high temperature probe now, so about 2 degrees.
Should be able to get to where
Yeah, if you can't reach over there, that's fine. Just anywhere into the pond will do.
Rail. That's exclusive.
Yeah, as long as we can get in deep enough, it doesn't matter. We don't need to be where the ripples are. No, we're yeah.
Alright, I can come up and to the left. See.
Since we're really nicely set up, do you want to fire bottles first and then do temperature? If we have to move? Yeah.
Just have a look down at your signal quick though.
Do a little bit more if needed.
Okay, so we're moving the probe up and watch that temperature. You can see that there's essentially no effect from that hot water yet because the hot water is buoyant and the cold water is underneath it. And so as soon as that probe crosses the interface, we should start to see the temperature climb.
Zoom in on the 4K.
That's pretty shallow.
it is right
It's
there.
jumping to 70, 80, 90, 100, 150, 150.
140, 150.
Went 150 first, 154, I think. Alright.
We're gonna try to get you just a little bit more.
I'm gonna program it in touch too.
Yeah, we're gonna do that. All right.
Alright, there you go.
It looks beautiful. Okay, temperature's rapidly 100, just past 200.
229.
$240, $250.
265. 270. 75. 67. 278.
Who has to
279 to 279.2. 279.5. 0.6.
What do you want to see?
I was hoping for 289, but we certainly got stable at 270, right?
279.
279, sorry, yeah.
That good?
Yeah, it was 279.
Okay.
Yeah. So mark that high temperature 279.
Very close.
Yep.
Because I was pushing you around a lot when I was in there. All right, so now for the major itself.
Yeah,
Is this magical hole that you want to see?
well,
No, so on the major itself. Where's the
oh,
vent?
it won't vent because we're upside down. Yeah, so
What's that?
We have this ramp right here.
You want to be right where.
I want to be in deep. Yeah, so as long as we're deep, but we don't want to push too hard up and plug the snorkel, just in case.
Bring your railer. Just look at it.
Roger.
I don't know you took the camera here.
Sorry.
rather be to the left a little bit more?
I'd just rather be deep. Yeah, it doesn't matter which way. Deep is you know, is good.
All right, zoom in on that nozzle. Like that's me just touching the water, right? Great.
Yeah.
And going up. I can get in quite a bit without any rocks falling.
That looked pretty good.
All right, I'll come back down a little bit. So how's that?
I'm good with that.
All right.
If we stable, we can go ahead and do a slow trigger.
All right, you got that thing?
Roger.
Slowly start pushing that ram out until you stop.
Roger that. Starting now.
What is this major called? Like, is this
Blank.
Major,
Oh, I'm sorry. Major blank. Major blank. Sorry.
Just keep going.
Yeah.
Tell me when to stop. Pause.
Stop there.
Stop.
I don't see the springs moving yet.
I was just making sure that
Yeah.
it pushed the major a little bit, so just gonna bring it up a little bit more. All right, go ahead, Nick. A little more on that.
Pushing again.
I don't see. I don't think we triggered.
I was stopping for that.
Hold stop.
Bring the ram in.
Coming in.
That's the press. As flat as it can go.
Yeah.
See that, Z?
Yeah, the trigger looks like it was too far in. Let's try it. Let's just try and push it again.
All right.
Roger that. Pushing.
Keep that high just in case. Here, let me try something else come out of it.
Coming back.
I'm gonna try to rotate it a little bit, Z.
Well, we have a good sample. That's not the ideal way to take a sample. That was J-Rod doing doing his magic one more time to get me a sample. Thank you, J-Rod. And thank you, Ben, for driving. We got a team here that can do miracles, so we were able to trigger the bottle. And we should have a good sample. Now we're going to stow that and try and get a gas tight sample.
Do what you can to get rust down. So get ready to take the lock off.
you haven't done the gas
Stay
tank
there
No.
with whatever little amount you can.
Should be fast. Should be fast. I hope.
Forward and forward just down.
There's a fish under the flange.
That's it. Perfect. So we'll slip on that. I'm gonna go for a smoke on. I'm gonna pour top. There you go. That was safe. Doing the gas tank as well?
Yes, please.
Gun just let it drop right. Oh, yeah. Probably gonna have to bring it back in, but let's see first. Okay. All right, so then let's see how deep it is. All right. This water line,
Well, I'm good with that.
what's that?
I'm good with that.
What's that? All right,
Yeah.
so now just a touch. Get ready, okay.
See, what is this gas tank?
Say when, Z.
Go ahead. Yeah, trigger.
Triggering,
Yeah.
pushing.
And release.
Release.
Yeah. We triggered.
Gas tank light.
Yeah, we got it. That's good.
Success.
It
Yeah.
works so much better when that ram does it.
Right.
Thank you.
Yeah, of course.
Where you gas tank light to be. You want me to find it? You want to go?
I want to go, maybe you know.
Oh, yeah, I know. We flew right over.
Okay.
I flew right over the ridge. All the way in.
Meters at 300.
Okay. Thank you. Nice.
And the silent screams of joy you hear from the pilots and the biologists is because that was the last water sampling we need to do on this cruise.
Woo! Not so silent screaming. All right. But all kidding aside, these are really amazing samples that are going to enable a lot of science, so worth the little bit of pain that we go through to get them. We'll certainly have a better view out the front once we get these bottles out of the way, so looking forward to that. Okay.
What would you like to do
Are we
now?
good? We are going to go about 30 meters at a heading of 300 to some of the microbial mats that we visited.
30 meters to the northwest,
Yep.
Yep,
what we just passed up?
yep.
Yeah, we flew right over the side on the way in here.
Yeah, so you see his trail that he did?
Yeah.
See where those two old mounds are?
Okay, so
It was like, it's like right over there.
Yep.
You just pretty much just back up, he came like right.
Mm-hmm. Yep, there's two different types of samplers on board here. There's a gas tight sampler that we use to measure the gases in the hydrothermal fluids. And there's also something called a major sampler that takes a parcel of water. It's a little bit bigger volume, but also provides a pristine sample that's maintained under pressure for looking at the other chemical constituents that might require a little bit bigger sample size for analysis.
Okay, shall we start, Victoria?
Let's do it. What do you need, John? John? John, what are you asking? I think we can lift off. Did you have something you wanted them to do before we leave?
No.
Oh, okay. I thought I
I'm discussing maps.
Got it. Okay. Yes, we can lift off.
Sorry.
Just that land right there in front of you. So, off to your right is clear.
See, is it, what's the volume? Is it 50 mils or 100 mils? See?
Something like 150 mils. I don't remember exactly.
So, I'm just going to turn around to my right.
All right, we're not quite sure about the internal volume of the gas sampler, but it's somewhere between 100 and 150 mils fluid.
Smack up. Nothing bad.
Yeah, bring you around. And look up on the front.
That mound feature, we're interested in the mats to the southwest.
This guy right here?
That guy, but where your hand is, that square, you're in the right, just right corner, we're basically, we want to go inside.
Something out here for you, John.
Yeah.
I'm just wondering if it's got the vessels.
Yep. And we're headed to that white patch in the upper left.
This one.
I'm going to turn around. Up north.
Everything you see right now? Yeah. Gotcha. You go to that area over there. You're probably gonna get.
Yeah,
Correct?
that's correct.
Can you look up a little bit when you pay that to? Okay. Yeah, there you go. That's what, just get that.
Yep.
Got it. So,
Just a touch south of where it's going. Is that?
Yeah, that's good.
Yeah, so we sample basically see the white patch sort of. So we sampled, I think, here a couple days ago. And that's generally what we're interested in returning to. Generally, exact coordinates from this.
It looks exactly like the marker that they have. And that's right there we are.
Looks like some nice fluffy mat there.
How big is the area of that?
We just flew over that.
Just flew over some that.
Yeah.
Yeah, I saw that.
Go slide back into it.
I think there are patches around.
We just flew over.
Great, so we're there. Look around,
Yeah.
find.
Like there's mat up ahead and there's mat to the left.
Yeah.
Or right of us. Yeah, right here.
Are y'all looking for an exact spot or just the
We're,
general area?
we're basically in the general area.
Because this whole
Yeah.
area is just all
Yeah,
that.
we're
Yeah.
we're in the right
Yeah.
we're in the right place. Thank you very much.
Thank you.
All right.
You want to go for 12?
Yep. So this is one candidate here, I guess. If it depends on how hard that ridge
Back
is.
up just a little bit. So you
But-
can see all this area right here in front of you.
Flat is better.
But that looks soft more out there.
Like
but
in
I'm
that
not sure.
that little
Yeah.
Yeah.
yellowish pond
Yeah, it
over
looks-
there.
that looks
That's
promising.
good.
Come down.
Possibly.
Show them this little snowy area right here.
Man.
All right.
Also
so we got
nice.
this right here.
Yeah.
Y'all want us to fly up and over?
Yeah, let's explore a little bit out here, but there's a site that's off to the left that looks pretty good.
I will keep my idea of where that little spot was.
One right.
Yeah, that's what you'll see all this. Just go east it. Speed it. I don't think where it was. This is a really big area underneath us.
Yeah. Oh yeah. Nice.
But this is getting back closer to the Z-Bank now. It's
Okay.
like halfway back.
Got it.
So. Snowy hills. It's winter.
Okay.
Winter in the Gulf of California.
That's so beautiful.
Really hot winter.
Like if it's really steep like this, that's not going to be good. It's horrible, but some of these areas on the flats, maybe. So let's pull up ahead here. See?
Right there. Probably. Is that camera on?
Yep.
There's a little finger going down. There's some mat out in the flats there.
Yep.
That might be also a candidate.
Yep.
So can we go explore this one that's straight out ahead of it? I think that may be what we would just flown over, possibly. Is that right? And then there's one behind that, and then there's a bunch in the distance there.
Yeah, we just looped around.
Oh, uh-huh, yeah. And that has a little chimlet on it. Maybe?
Beginning of a housing tract.
Is that where we record?
No.
No.
Sorry.
No.
I just went over
I
the
think
hill.
we're off to the right a bit. Does that look like a porch push down?
Well, that's what I'm wondering.
Y'all looking for some venting? Active venting?
Active venting is great. We're looking
Yeah,
for places to
places.
take push cores. Sit down, take push cores.
There's some venting at the back of it. All the way in the back of the mat. There's a vent.
In there?
Yep. Right.
Yeah.
By that bright
yeah,
white spot.
Yeah, there's some shimmer coming off of that.
Yeah. So these are rocks.
I think this may be horrible here.
Yeah.
I don't think this is
No.
horrible up there.
No,
Yeah.
that's up on
Yeah.
the platform.
I'd like to try to So let's keep this place in mind. I don't know if can we put a waypoint down here? Yeah. Little venting mat. If nothing else, that could be a home for the house. We'll see.
Yeah.
There's that ring blue mat on around.
Yeah, the blue mat is where we got, I think the bias samples came from blue mat, and some of our hottest areas were blue mat.
Yeah. I'm just not sure that's coreable. It's on a slope.
Big park?
No, we're gonna keep.
There's more man on my right,
Okay, let's take a look at that.
right and left.
Areas that are kind of in the flats are good. Maybe they're ponded.
John saying right over here.
To the west of where you have that marker.
Oh,
So you're going to be
It's kind
I
of
think the pink land is leaking out under the crust. It's where it's leaking out under the crust. But it looks like it's still on hard rock.
yeah. There's some blue.
That's nice.
That's what the top is.
Yeah, I think that's pretty hot.
Yeah. That's venting up in the corner there.
Yeah.
I don't know though. I mean, it's all rock. Are we still? Honestly, it almost looks like we sat here at some point in the past.
Up against it, attempting
Yeah.
to core in 2018.
Maybe. Yeah. Okay.
John said he found the location of the spot yesterday.
Yeah.
Over there.
It's from the photo house.
Okay.
This patch right here.
Yep.
It's the better Jacob's marker.
The far left one.
Yeah.
Yeah.
Which is only about 20 meters away.
Yeah, it's not far at all.
Yep.
That's the Sebastian flies.
Yep.
You know, that little saddle. Where there are two rooms, that little saddle line we saw. Did you see that came in?
Where was that? There's a Xeno. Yeah.
So Victoria,
Yeah.
the farthest left green blob on J-Rod's map, the right map, is where we cored a couple days ago. So
Yeah.
we're about 20 meters up to the right,
Okay.
and then so
So we could go.
so if we headed towards it, it might be in a more coreable
Yeah.
direction.
Okay.
Did y'all see the pink sign?
Let's try
Yes.
that. Yes.
Oh.
Very, very nice.
Here, I'll zoom in on
We
it
should,
just
we should get a good frame
because
grab.
Xeno's in the wild, stalking the clam. Yeah.
Like it's attacking his map, but it's a
It
nice
does look
proximity.
like it's.
Looks like
Oh.
a Frankenstein.
We're moving too much. I can't do that zoomed in.
If you keep it steady, I'll just fly close.
Okay.
Rebecca's been getting some good frame
Yeah.
grabs though. She's got a itchy trigger finger.
Should we try to go over to the?
It's not very far. We can swing around and come back.
Okay, let's give it a try.
Just go.
So down to the
Y'all want to
left,
go to that
right?
place that John was talking about?
Yeah, let's head that way and see if we find some corbel.
John. You want to split the difference?
Head, yeah, head to the one that he pointed out.
The first one? The one that you pointed out?
I mean, when you come up over that rock edge
Yeah.
right here, this bacterial mat all on here, and then it curves down.
Yeah.
And you can see
Yeah.
the photo mosaic has a bit of a shear.
Yeah. We want the curved down part because that's probably more
So I think if
corbel.
you just follow that rock ridge, you'll come
Yeah.
down off of the
Going the other way down. What do you call it?
the bits that fall off. Or the geology of the trellis.
The hand walls. The circ.
We're going to that right now.
Thank you. Yeah, there you go. That's the ticket.
Okay.
Yeah.
Okay, so now we got
Wow.
the sediment.
Yeah,
Yeah.
that's
That
looking
looks-
better.
That looks good.
That's looking good.
That's all the stuff we just grew over. He's just taking a turn out into the building.
Oh, well, whatever. This angle looks really lovely.
You want to stop here, or?
Yeah, I mean, that was the stuff that we just grew over.
Yeah.
Keep coming around.
Yeah.
You gotta go 180.
But this does look good.
It does.
Is there any reason why we couldn't do it here?
No. No.
Um,
we could just stop and do it.
Do you want to stop here?
Yeah, I think we should.
That looked good.
I think we should
Yeah.
try that. That was looking
Yeah.
good to me.
Yeah.
Yeah.
Just this way, here's your skills. You got good bottom back here, so just that.
Climb tracks over the fresh snow.
That's right. We do one in the clams and one in the mats. Look at the crab.
Burrowed clams in there.
Yeah,
It's gotta
it's
be
in-
soft.
Yeah. A very muddy clam or crab.
Do you have an idea where you want to pour?
Yeah, I think we're gonna do cores in the mat area and also maybe over some of these clams, which you can see from their siphons. So however you position yourself, so we can try to target that. And then we'll try to do some temperature probe measurements. Yeah, this is good. It's nice model.
Yeah, I like this.
Oh, and nice. So interesting how the you get deceived with the lighting.
It's just you're on it down there. So you're going to get no teeter or anything.
Oh, yeah, okay. Yeah, it's just super zoomed in. That's why.
Well, more than likely. I don't know. But-
Okay. Are we parked? Fantastic. Let's start with the temperature probe. pester the crab. He's awfully muddy.
I bar the camera on.
Yeah, you can.
There you go.
Let's see if I can point it.
Peanuts, was it pig pen? Always had a lot of ducks. That's pig pen.
Oh, I picked up some extra rocks with some dorvalaids. Right, so we're here up to the a little bit northwest of Z Vent, where we just took our major and gas tight water samples. And now we're going to set up to do some temperature probe measurements in the sediments to look at the thermal gradients, and then take sediment cores, push cores, hopefully done in the proper way, or just a single push into the sediment. And this gives us a really nice depth stratigraphy of the geochemistry and the microorganisms that are sort of responding to this mix of overlying seawater oxidants and these reducing fluids that are coming from the hydrothermal vents below. And so we want to relate all of that microbial ecology and biogeochemistry to the steep thermal gradients that we see around in the Auka Vent Field. So one of the questions we have is where we find these localized patches of clams. Are the temperature gradients different than what we see underlying the microbial mats? And this is a really nice place to do that because we have this really patchy distribution of both organisms here.
Well, that's on 0.4.
I was going to say the temperature's going up already.
Good spot.
That's
It is. That's,
it's the lazy manipulator temperature probing, just bad at it, throw it in. All right, let's start in some of the white microbial mat, and we can pick. Let me see if I can find a spot for us. How about off here to the right of this clam patch?
Zoom out a bit so I can see.
Yeah. See this sort of bullseye ring?
One more time.
Right in here,
Okay.
maybe? Or if that's too far, you could do down here. Yeah.
I'll borrow the camera. Sorry.
Yep, go for it. All right, Connor's guessing it's going to be 20 degrees Celsius. At what depth? That's the question. That looks good. All right. We're in 5. All right, you're on. As far as I know, there are no hydrothermal vent scallops down here, and we certainly haven't seen any at these sites.
6.3.
6.3. Is it holding? Okay, 6.3 at 5 centimeters. Let's go another. Yep, please.
What's that?
Degrees. That seemed pretty stable.
Yeah.
Okay, we'll go with 12.6.
Another 5?
Another 5.
This is correct. That one.
So we still have.
I haven't found it. That takes a test course.
Thank you, J-Rod.
Uh-huh. Have fun now.
We'll have fun. It's always fun. 8, 7.
Ekin, we did get the hot and aerated out of the slurps yesterday. It ended up in a totally different slurp bucket.
Yes. Evaporated from one.
Yeah, I don't know. It just
Slurp
snuck
bucket.
around,
Yeah.
cruising the neighborhood in the slurp canisters.
Yeah. 18. All right. Let's go with 18.31 or 18.3. Let's get it out to the 100th. All right, we can go another 5.
It's like our depths out to 5 decimal places.
All right, 21. Yeah. Yeah. Yeah, snakeworm. Snakeworm was wily. $23. $24.
How long does it take to set up for heat flow?
To set up.
And do it like full amount of time?
Probably 10 minutes.
The reading itself is 9 minutes. So
Yeah, the setup is a lot more.
7 minutes for reading, right?
15 minutes?
7 minutes for reading, but 2 minutes for the
for the
equalization.
calibration. Yes.
So 15 total or so? I was just wondering with Dave's Slack message.
25. Yeah, I know, we already talked about it.
Yeah, that must be. Just asking.
I was meaning that we already communicated with them.
That's what I know.
Okay. Sorry. 24. 26. 24.6. How about 24.6? All right. Proceed, Jared.
Another 5.
Another 5. 5, 5, 5.
Maybe.
Are we hard?
Just got one little.
Oh.
Oh.
Well, J-Rod didn't think it was hard.
My first 5.
As he said, normally this is easy, as he was picking up the chimney earlier.
Yeah.
It's funny. Perfectly on film. One of the students was like, it takes a lot of patience to be an ROV pilot. I'm like, yes. Yes, it does. You observed correctly.
27.8. Maybe we can get to 28.
It's 28. 28.
28.
I was gonna say, there's nobody flying. There's nobody flying.
All right.
It's just invisible.
All right. Let's go with 28.1. All right, we can retract the probe. What? Yeah, we're.
But neither will a push cord, so not deep. So.
Yeah.
Yeah.
What's been your max push cord so far?
20, 21.
Oh,
Yeah.
yeah, all right.
Okay.
So you just want to hold on to it.
Yeah, Claude.
Yeah, it's sticky. These won't fall out.
How about our temperature? Gotta get our temperature probe back down. Or no, we're gonna do another temperature probe measurement in the clams.
in the clams.
Live clams?
Live clams.
All right. Let's see, I'm curious
Or
about
like
that too.
Pro vet.
Let's go within here. Just tickle those
Dirt
two there.
Yeah, in the dirt part.
Yep.
They all have little anemone caps. Gets in the way of your siphons. You gotta be a birch.
What you?
Somewhere else siphon. Pretty good at that. Trying to see that second. There we go. Siphons. That's a perfect image.
Mm-hmm.
They have little fingerlets on their siphon, so stuff doesn't come in, like a filter. Finger filter. And that
Can you-
anemone is.
huh?
Bend this story.
Yeah.
The anemones are not on the clams. Another thing.
Tubes. There's the muddy.
Mm-hmm. Sometimes they end up covered in sediment like that. Found no difference between them, the white ones and the muddy ones.
He's in disguise except for when he's on.
Yeah,
He should
Wrong
stay off
subject.
the white mat.
the camouflage is not working out. Look at the antennae are so covered also.
All right. 8.8, 8.9.
What a clam shot. Can I?
Huh?
Can I take this just for a sec? This is so cool to see. Alright. Down to a clam.
Yeah, I can't go much. Can't
Yeah,
go
that's it.
much.
That's all.
Yep. 10. .3. Let's go with 10.3. Okay, we can go another 5.
We should probably get a few of these vescomides if you can scoop a few. Greg and I were talking about that yesterday. Although he got some little ones, didn't he?
Are those the same clams? That siphon in the middle looks different than all the other siphons. Is
I
that
think
a
it's
different
just
clam?
no, it's just head
It's just
on.
the way he's got
Yeah,
it.
yeah, yeah. Something like
Okay.
that. I think if you look down in all of those, they would look like that.
Oh, okay.
Okay. Maybe don't. I think it's low priority. Yeah. Time crunch.
Yeah,
You should get your push cars. You push car over. Problematic.
We should sort that callity and show them a finger. Leave home.
If we could just blow at the.
Yeah, did we bring the clam brush?
Lamb track.
Toothbrush. Yeah, look at it go.
Yeah.
It's cool.
How long did it take him to get there?
100 years. No.
15 degrees. Is it holding?
Yeah.
Okay.
Sure is waving its antenna.
We can go another 5, please. 15.5. Temperature. Okay. Thank you. 17.
The 2 feet is a bunch of
18.
punsters.
Yeah.
Science is colossum.
I
Y'all are clamped
Yeah,
for
no,
time.
no.
It's just been going on and on.
That was days for days.
Days for days.
They're making me smile.
Let's look. Whoa.
Scale worm.
Going in between, like slalom. Pardon me, coming through. Oh. So, yeah. Oh, I can't. Uh-oh. Oh, don't
whoa,
panic.
Whoa. I'm
Scale
out.
worm, don't touch me.
I'm out.
This is also weird. No,
Yeah.
that's just,
What is that?
I don't know. It looks like
Did you get a tube stuck in it?
a leg. Don't know.
It's batoned.
Or is it just
All right,
it's
19.
not covered?
19. 19.3. All right, let's try another 5, please.
I'm impressed. They're in some,
20,
they're in some
21.
toasty sediment. Coming up the surface.
You know,
Degrees
it's
is
like
no
a
joke. Roof dew gets
no,
all
no.
over
This
bland.
is this is deeper.
No, but it was 16 at the 10.
Yeah,
6 to 16.
yeah.
Clams will hit pretty high temperature.
They don't normally.
I don't think so.
Yeah.
Cool.
$23.
Eating. Look at those mouth parts.
I know.
Going.
It's freezing. 23.3, 23.4.
And those little brushes.
All right, 23.4. Let's try another 5. See if you can get in there, or if we're gonna hit hard bottom. All right. $25. $26. Gradient these is even a little higher here than it was in that other expense. Similar, but
That's what Rebecca was saying.
yeah. 27.
Coming over the temperature probe.
27.
Crap.
Don't mess it up.
It's gonna dig. Cool.
Taking you on. All right, let's go with 27.
27.
And Jared, you think you can get another push in there? Still holding at 27. $7.5.
It's a pretty Good size crop. It's been around the block a lot.
Mm-hmm.
Yeah. Been around the block a few times.
It's like an amplifier.
Mm-hmm.
Does that look right? Won't see legs, but
What?
I think it was like an amplifier thing if you've done it before. Some kind of or something.
No.
No, you don't think so? Okay.
27.5.
I mean, just attached to it. I mean, they do. They might hitch a ride, but I don't know. Feeding on
I
it.
don't know, it's got his head. If it is a live thing, it's got his head.
Okay, we can retract the probe. Yes, go for it.
I'm not sure. On the legs or something? On the leg?
I didn't see any legs on it, but it looked like a body of an elongated thing. I don't know.
Like hitching a ride?
Yeah.
Alright.
Okay.
What are we doing next?
I'll take some cores and the clams.
Sure.
Let's do it. We're gonna try to take some push cores and the clams
Are we done with the probe?
for the moment,
Just for the moment.
but you could keep it.
I'll keep it.
Yeah.
Alright, which ones do we want to do?
So far we have. Let's do number 1. The film.
Yeah.
We'll do number 1 and 2 in here.
These are meant to be lower temperature than day 2.
Yeah.
What?
These are meant to be lower temperature than day 2.
No.
I really wanted it high temperature. So look around. And we'll with another 2 cores. You have enough push cores for the
Yeah. But we're here and we haven't gotten any clam cores, and it's a habitat that's representative. So maybe but no, I was hoping about saying that.
Are we just in a different location on this now?
For a little bit.
We are, yeah.
Doing number 1?
Yeah, everyone would be great. And this, Jared, this is one that has the film on it, so we'll let it
Turning towards us.
marinade in the sediment for a little bit. Do you want me to try to take it over, Glenn?
If it messes up your sediment, then don't do it. We don't. We've gotten some at this point.
We could try with the live one, so let's try.
Okay. Yeah. Okay. Yeah. Okay. This
So
looks familiar.
we're sampling
Yeah.
here,
Yep.
and we're
Really?
Yeah.
How big is that feature? I see. And so you know where this is, but you don't want to sample there, so you're looking
No.
for hotter areas.
no, just to get there, coming in this direction, we came
got it.
down.
Yep.
We saw that, and so
I see. So
and
it's
so
will be hotter.
we're interested to check it out.
Yeah.
Yeah. So yeah, we're headed here,
Got it.
but
So you just have to continue on in this heading, and you might bump into
yeah.
Victoria's choice.
No, not this
Okay.
heading. Not this
Not this heading,
behind us.
but
The way you
the
think.
way.
Okay, we're gonna go into that clam patch and then try to avoid the area we just messed up with the temperature probe.
That's actually a bigger feature than I thought. initially.
Yeah.
So, how about, can you split the difference between these two anemones and go, well, maybe, where should we do this?
Zoom out and get something
Yeah,
closer.
yeah.
That's 24 meters.
Oh, yeah,
Maybe
yeah,
if you
that's
can reach
good.
this guy back here.
It is. Okay. So to speak.
Just like put it right over the top of him.
We look at it in
Further out. Might have to go closer.
the temperature. There's the islands there.
Yeah, if you can put it right over, do you see
Yeah,
this
yeah.
clam that's in the back?
Stuff over here.
I don't know if you can reach him or not.
I can look closer. I can look closer.
Oh, you're right.
It's further out.
It really is.
It's the LiDAR.
Yeah, and if that one doesn't work, we can find another one.
LiDAR and the multi-beam. The relief changes a little. It's the tuberose bushes. Because the tuberose bushes show up well in the LiDAR.
yeah,
because they're
totally.
soft.
Yeah.
And so you can see the difference
Yeah.
between this being the definitrine.
Completely. And that being the tuberous. Yeah, absolutely. That's very cool.
We're gonna have to move
Is that
forward a
too
little
big?
bit.
Okay, well, would it work to do something in the front
So
here?
basically, this is all those
Instead.
bushes on top of the marker. So cool. Then in the photo mosaic,
Right in here?
you can see the red heads.
It's back further, I think.
Is that a Wayne?
I can't tell, but if you're over the clam, then yes.
Are you stop here? Are you going for a clam?
Yeah.
Maybe one with an anemone on it.
grab a clam, just point one to me, and I'll do it for you.
So it's right under.
Straight down here.
Yeah, let's try it. This is right at that edge of the transition.
Down it. Hitting hard there.
Okay. Well, we can, and then we just
Let it go.
let it go. Nope. Oh. Okay. All right. So if you can reach number 2, let's try that one.
Can we do number 3? Is that alright or no?
Number 3 we used up above, so I'd prefer. We used it as a scoop.
Is 4 easier than 2?
Yeah, 2's fine. I just, like I said, I just have to
If
move something fast.
yeah,
That'd be good.
yeah, any of the other ones are fine if that's easier for you to
That you're gonna use them all
reach,
later.
but we are gonna probably use them all.
The whole. Yeah.
The whole does.
Yeah.
Watching out.
That's sad.
Oh no. Yeah, we did get 6 back on.
Hmm?
Before we go to the surface.
Yeah, we have to tie 6 down.
Right.
There's nothing in 6.
No, but it'd be sad to lose the core.
Yes, it would.
One of them's not secure.
Number 6.
Oh yeah, it is.
It's half is lost.
Like lost.
We're not sure.
But you're gonna move 5 to 6.
That's
doesn't help us.
Because you did 5?
No.
Collected 5? Oh.
But 6 was empty.
Oh. You don't lose them unless they're filled with something that's volatile, right?
Probably. Once it floats on.
But it won't really a jam on the yeah. Murray doesn't have collars around theirs. They never float away. It's just
And we didn't have collars on them when we started the dive in 2018. It's when they started
Yeah.
shooting off like rockets.
But I'm saying when they're empty,
Yeah.
you don't lose them.
Hmm.
Yeah, no, they're filled with something volatile.
That's what happened. That's why you started to call it.
Yeah.
Once we got up these strips and stuff, bubbles started coming out.
Yeah.
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 So what's your plan for number 6 before you file?
They wanted to, so the number 6, the cap might have fallen down that side, or it might have ended up great. Might still be attached. It won't break if you can't see it because of the house. So,
But it actually may still be attached.
so if it's still there, then you can put it on. Once we
Is it aluminum?
Yeah. Yeah.
That's the added benefit of the heavier
Yeah.
in your rack camera.
Roger.
Hmm?
They don't let it fall on the surface very long and it all makes it.
Right.
The only danger would be biting the surface.
Mm-hmm.
I think they're pretty quick about their recoveries.
Very quick, very efficient.
Yeah. Collars add some time.
Yeah.
There's another locking mechanism, because even the
Okay.
collars allow the cores to come off the stalker.
All right, so Jared, tell me where is an easy reachable spot for you that's in the clams?
It still disrupts the stalker.
Can we do it in front of where one is, or
Clicks in right above them, so it keeps them compressed.
Yeah. Yeah. The little hats that we had before.
like could you do it right over
Tighter.
Same idea. Like
Same
it just
idea.
goes one way.
over this one here?
Tighter.
Does that work for you?
And they were better at holding it in place than and right
These
there.
didn't come off. Just do
This, yeah.
Hmm?
And right over there, it was definitely.
Yeah.
this stuff is fine.
Definitely. Yeah. Yeah, I think that's exactly what's happening. Some of the most cores, so they're coming up and stuff's going out.
Yeah. And we see.
And that's what we
They were thinking they were seated in the tent. I wonder if they would be amenable to.
Is that what you want?
Yes, please. Over, just right over the clam. We can do it. Oh,
Still wondering now.
yeah.
It's too big. Is that
Go,
an
yeah, go. Maybe go over to a spot that doesn't have a clam. I think because that's just gonna push it all the way down. Sorry,
You hear about
give it a little shake.
accurate samples, or you have to hear about fewer samples that are actually accurate.
Right of this clamshell over here. Would that work?
Is it? I just don't think it's disrupted because they pull them under the sled overhang. These are exposed.
It's way out.
So that's part of it. Is that
Yep, go for it. All right. Great. Yep. Get a shot of it. Okay. Fantastic. Yes, we can pull it out. Yep. Nice dark layer.
But
Transition.
because the quivers don't look. Yeah, it's gonna doesn't do any good. Quivers are because that's rigid. It's a quiver that's the ghost clamps, and that will move sideways. They will tilt as they flex. Yeah.
So typically one of the main differences between the underlying sediments in the clam beds versus microbial mats is that the clams actively pump seawater into the underlying sediment layers, and this in effect brings these oxidants into the sediments around their foot that extends. So these organisms can basically travel several tens of centimeters up the ground in the sediments. And so that dark layer you see there may be the extent of sort of this oxidation reduction front, with the transformation of minerals in the sediments. So that brownish color up above is all the well oxidized layers. At least that would be a hypothesis just based on color alone. We'll need the chemistry to be able to confirm that. Okay. Nice.
Can we move them to the halls of the basket instead of water sample? Maybe that could be a solution.
Do what?
Yeah, one of these would be interesting. Yeah, because so maybe rather than another biobox, I wonder if they could attach a biobox. Maybe not here. And then move these to the bush. That's what I would do. Yeah. Yeah, let's see. I like that.
Oh, we can pick up the other core. Thank you, Jared.
Yeah, so we're ready to pass this back to clear up. Yeah.
Well, that supports this idea of the bioturbation,
Yeah.
oxidation of the top. So this is a sulfide film, for those of you who are just joining, that's attached to the outside of the push core. Core is quite short, actually. Look at it. We see only brown staining at the very bottom of this film that's sensitive to sulfide, and it binds it with a silver emulsion. And so it gives us a physical indicator of where sulfide is. And this looks really different than some of the microbial mat cores where we've been sampling up to this point.
Could have been a clam situation there.
Clams.
If the clams go inside,
Yeah, I
then
think
it's
it probably did.
bump
Yeah.
up against them.
So that means number 2 will be our geochem core.
Yeah.
I want to take another one, but
What's next?
do we have time to go over to the other site and set up? Can we go to another spot to core? What do you think?
Okay, how far are we going?
Not very.
What time? Yeah. Okay.
Excellent. Okay, let's go to the place where we poured initially.
The novels.
Yeah.
Okay.
Behind this, yeah.
Yeah, so we want to go.
I want to go to that spot where John pointed out to us. It's where the red soap is.
Yeah. Yeah, so we want to go there.
About face. U-turn. Maybe you don't have to do full temp profiles if you've got something. Do you want to see what the temp profiles were on the second diet?
They were hot.
I know, so you'll know. Right spot, just the first 5 centimeters.
Mm-hmm.
We probably don't have time for a full profile plus
No.
course plus a house.
That's what I mean. Well, the house is not going to happen.
This would be easy to walk over.
Even if there's no venting.
No, but they're likely, if we're going to be.
If we're in the right spot, there is venting. I guess there has to be 180-degree sediment, huh?
Yeah.
That makes sense. Alright, so we should be coming up. So
What are we looking for?
looking for an area of white bacterial mat which is sloping down from this carbonate. Maybe
Bacterial mat.
Right here.
so.
Looking like
Can't see.
Do you want me to zoom in? What do you want?
Is it all clams? I thought I saw
What's
that.
off to our left?
Yeah, that's what I was thinking. Yeah.
Yeah, there's someone on
Yeah.
Or
The
Those
clams.
are
There we
all
go.
in in.
Wow, they're loving it. Yeah. We definitely saw clams this density on day 2.
Yeah.
So we've got to be kind of in the right area. Is that coral? Can't tell.
about it.
Okay, we passed by the spot.
Yeah. We could try.
What do you want to do?
We could try in here. I see a little vent too.
You do?
Yeah, off to the side.
Yeah, yeah. I think gotta go with that, yeah.
Do you think you could set up and core in this
Area?
area? It's nice blue mat.
Just gotta jiggle some clamps around. Push them out of the way.
Your clams are a pain in the butt.
Always are.
Blue mat. That's okay.
Under us, yeah.
Can you zoom out a little bit?
Where's your venting fluid?
It's this little chimney right here. Maybe.
I did see it when you were sitting down.
Blue mat.
Fishy, fishy.
Okay.
No?
Put it down. Look at that beauty.
Give it a poke.
Okay. So, are you down?
No.
Fantastic. All right. So we're gonna do a temperature probe measurement. Hopefully, further to the back right, if you can, just so it gives us some real estate to do push coring, if it looks good.
Further to the back.
Yeah. So like maybe.
Somewhere to go.
Yep.
Maybe this?
Hmm? Yeah, that looks somewhere in here.
Something, right?
Yeah. Yeah,
Because it's in
road
some
there.
sort of-
Yeah, please.
So you could put also that. So that's the only that unit, and this is giving it away a little bit. So,
My clam's been
oh yeah, but we must have done that.
maybe. Seems weird.
It's 5 centimeters.
Is it hard? Oh, okay.
Right in.
Okay, good. All right. I see some shimmering
Yeah, above that.
water right in here.
Right, right. It's it's coming out of
Yeah.
Yeah, that's. I think
So-
that's the main.
We could put the house there.
Yeah. Even if you don't pour. They pour it out. I think that's the main.
Okay, 10, 11.
First to try
Let's go with 11.
Oh, because that's the goal.
disturb
Yeah,
the
yeah,
flow.
Okay, go another
Yeah.
5.
Get it gushing.
Right.
The house.
Is that the? You just want it's for colonization
Yeah.
for April or for
No,
some
no,
number of days
at
from
the
now?
end of the, yeah, our last,
The Z day.
yeah,
Yeah.
on the 9th. All right, temperatures are coming up. Shauna or John, can you?
John, you are capable. Okay. Go another 5 centimeters. Or 15. Stable enough. Yeah. too bad we're not really in the area.
No.
Didn't see, we passed by it though. X marks the
Maybe
spot.
looking out the wrong window.
And that, the pink dot was the exact coordinates of where we pushed for?
Is
Did John put it?
is the approximate coordinates. It was because it was covering a large area. It was covering the general map from the photo mosaic.
But we have push for coordinates from the second dive.
We do. Yes. 5.
Yes, please. That's 17. Still 17.
Yeah.
Okay. It's at 17 at 10 and 15 centimeters, so no change. Okay, so I think we can be done with that one. 17. Okay, go another 5.
Try another 5?
Okay. It's not changing at all. Oh, it's still 17.
I see you were,
Yeah, we already
when
did.
you pushed it in more, wasn't
So it's still 17.
I see.
So we can-
Okay, we can actually just leave it in there and then we'll do a push core and we can pull the, if it'll stay.
Yes. We actually, on the dive plan, is the coordinates from those push cores. So, do you have the dive plan? Because those have the exact coordinates of the site we wanted to go to. The second site. And we pulled them from the sample at sea log. It was dive 471. And it was push cores.
Or you could do 3.
3. The whole Wi-Fi on the ship is sagging. This one.
We did 4 already, right? No?
We did 1 and 2.
Okay, well we're gonna do 3 and 4 anyways.
That was the plan. That was
3's the one you used as a
Yeah.
scoop.
Yes.
You can shake it. Shake. Or is there stuff in it?
But we're gonna take 2 anyways, so we might as well. We're gonna have to use 3 and 4 anyways. So.
Yep.
So that's the mat. That's where we push for it. Yes, it's pretty close.
Close,
We're not just not finding the exact mat. So we are in the vicinity. Yeah.
Yeah, we just don't have the luxury of cooking that.
Yeah. Exactly.
Anyway. I was with you, I just thought they'd gotten the gas tank before they were here.
Yeah. Okay.
Alright, confirm.
All right. Can you get one in here? Is that possible? That fish, what are you doing? Yeah, there.
That's a fish that needs to spend more time in school.
Wow. What are you doing? Is it hard over there? Hey, hey, no, no, no. Get out. What a brat. Okay, how about you just... Okay, let's go over here.
That's a first.
That is so uncool.
My core so bad. It's just
Okay, alright. Jared, does it work here?
Right where I'm at?
A little bit over to the left? Yeah, like in there?
There?
Yep.
Yep.
Okay.
It's hard. That's, of course it is. Okay. Alright. Oh, two of them. What are you guys doing? No.
There's a clamp there.
Yeah.
Alright. How about... I do think we're just gonna have to go over here and let's goose the fish. Get him to... Right where his tail is. Seriously, gotta move. I am. Get out! Wow, hard. It's hard on all sorts of levels here. Okay. Wow, what are you doing? Okay. Ugh. Can we shake it out?
Zoom out. Zoom out.
Yeah, I can. If we pull the temperature probe out, is there a spot back in here that you can get? Yeah. Because I'm thinking this is all hard. I know. I don't know what else to do. Like, I don't see any other place we can go. Or
Dave Caress says your fish problems are about as bad as ours around Extrovert Cliff.
that's what I was saying. But he has to pull the temperature probe out to do it.
It's like the sable fish in the mapping sled.
Okay. Yeah, it is totally. Okay. Awesome. So just. Maybe they like the warm water coming out. We may just get one more. We'll see.
It's going to be Sean here.
Okay.
Is that
We want to be over here.
The white stuff.
Yes, in the bluish white, in front of where you took the temperature probe measurement.
That's what wine.
Yes, in the actual blue,
White.
and not over whatever. If there's a clam there.
Yeah, there.
Yep, that's perfect. It's compressing though. Let's see.
Leaving it or?
Keep pushing. Okay. Now see what happens. Yeah, you can leave it in if we can do one more. Otherwise, if we're running out of time, we just pull. So number 4 is available. Hmm? Yeah. That big blob of mat.
Yeah.
Thanks, Jared. Let's hope it holds. Get out of there. Get serious. Oh, Jenny, don't do that. No. Oh no, are we losing it out the bottom? It's gonna be very, very short. If any. Okay. So go ahead and what I would suggest, like if if we're short on these tops to secure them, since we lost one, I'd rather try to put it over 3, since this one, it doesn't look like it has much sediment in it.
Wait, this one on 4,
Yeah.
and then 101. Huh? 101. There's one on
No, one has stuff in it.
101?
Oh, 101. Yeah, 101 does not. Yeah, that's true. But yeah. Yeah, that's true. Yeah. Yeah, that's okay. I don't know if there's time, otherwise we can just pull.
I don't think it could be a marinade. Can we get it?
No, you don't need to marinate for this one, but we could try to do a quick poke.
Okay.
Just add a little bit more down here. Okay. So it looks upstairs again.
Turn the water on it.
Give it a try. Yeah, I don't think it's gonna hold. It's okay.
Chris, you want to try?
We could try over to the left if, just to see. Maybe if you're closer to the quiver, we can just wrap it up. Anywhere in there is fine. Okay. Go fast. Nice, Jared.
Clamshell at the bottom, that doesn't help.
Yeah, it's good. Great. Thank you, Jared.
Right, Jeremy. That's
ROV bridge, say again?
we're just gonna come off the bottom here.
Okay, thanks Adam, off the bottom.
Thank you.
There. Yeah, thanks.
Yeah, we're good. Yeah, thank you. Okay. It's a lot of clams and anemones. All right, thanks everybody for joining. We're pulling off the bottom now. Reached our 5 hours plus mark of bottom time.
Stop.
Okay. Great. See if that little piece of chimney makes it up. Yeah, could happen. I don't know. There it goes.
Those are my adjustments to that standard.
Yeah.
We finally picked it up and just without meeting to that.
Okay.